हाँ सर, आपको ईमेल आईडी.
So a very good morning to each one of you present here. We'll start our program with the national anthem. So I request each one of you to rise for the national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता। पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा। विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा। तव शुभ नामे जागे तव शुभ आशीष मांगे। गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे।
Thank you so much, everyone. So a very good morning to each one of you present on this virtual platform today to celebrate the National Statistics Day 2021. In recognition of the notable contribution made by Professor Prasanta Chandran Mahalanobis in the fields of economic planning and statistical development in the post-independent era, the Government of India has decided to designate 29th June every year, coinciding with his birth anniversary, as the Statistics Day in the category of special days to be celebrated at national level. Friends, it is said that यह पठति लिखति पश्यति परिपृच्छति पंडितान् उपाश्रयति तस्य दिवाकर किरणैः नलिनी दलम् इव विस्तारिता बुद्धिः. Which means one who reads, writes, sees, inquires, and lives in the company of learned, his or her intellect expands as the lotus petals expand due to the rays of sun. So, the Department of Statistics is giving you all an opportunity to read, write, see, inquire, and most importantly, to live in the virtual company of eminent personalities and interact with them, which will help you to expand your intellectual horizons. This program is very systematically designed under the guidance and leadership of Dr. Asha Jindal, who is the head of Department of Statistics and the convener of this conclave. Now I invite Dr. Asha ma'am to give brief introduction of the conclave. Over to you, ma'am.
Thank you, Pratiksha. Good morning, each and everyone present here. I welcome Dr. Niranjan Hiranandani, sir, Principal Hemlata Bagla, ma'am. Ma'am, your welcome address is there. Despite I feel being head of the department, I should welcome, and all other dignitaries, Dr. Rajesh Singh, Dr. Chaturvedi, Prashant Nair, sir, and all other my friends, my senior colleagues. I welcome you on behalf of Department of Statistics. National Statistics Day is celebrated on June 29th every year in India on the birth anniversary of Professor Prasant Chandra Mahalanobis, a renowned scholar from the field of statistics. Statistics, which is widely seen as the grammar of science, is integral to research in all branches of knowledge and forms the base of quantitative research. It provides the groundwork for policy decision and authentic information in the quest for innovative solutions to problems in sciences, social sciences, government policy documents, and governance issues. It is the mark of a truly intelligent man to be moved by statistics, said by George Bernard Shaw and lived by Sir Mahalanobis. We have also been witness to the role which statistics has played in controlling the ongoing coronavirus pandemic by various nations, including India, and it is our best bet in the continuing steps that are being taken in this regard. Since past 4 years, on this occasion, Department of Statistics of KC College has continued the practice of organizing lectures, seminars, statistical concept-oriented competitions for students, data championship, paper presentation in best possible way. The role of statistics as a tool of analysis has expanded immensely in the past few decades and also continuing our legacy of past 4 years. This year we are celebrating National Statistics Day by organizing a 4 days national conclave on recent trends in theory and applications of statistics. For this, our department has received an overwhelming response of 300 participation. Considering the wide dynamics of statistics subject, I look forward to the generation of new ideas and vibrant discussion which will open up newer vistas of inquiry and research. I sincerely acknowledge all HNC board authorities, Principal Madam, all advisory committee members who gave their valuable suggestions and inputs to have wonderful, academically sound and thought-provoking conclave. Last but not least, I sincerely appreciate my fellow colleagues who stood besides me and adding the rainbow colors in organization of this conclave and even from the last 4 years, all the activities which happened in the Department of Statistics on National Statistics Day. Thank you.
Thank you so much, Asha ma'am. Friends, it is said that a boss says, go ahead, and a leader says, let's go ahead. And we are very fortunate to have a young, dynamic, and charismatic leader who always motivates us in all and is always with us in our journey, Dr. Himlata Bagla. She is the principal of Faculty of Science and Technology, or HSNC University, Mumbai, Honorary Director of KC College of Management Studies, the Director of Niranjan Hiranandani Group of Real Estate. And now I would like to request our ma'am to deliver the welcome address. Over to you, ma'am.
Thank you, Pratiksha. Thank you very much. Trustee of HSNC Board and Honorable Provost of HSNC University, Dr. Niranjan Hiranandani. Our special guests and authorities on the subject of statistics, we have our Mr. Mukesh Jain, Mr. Prashant Nair, Dr. Rajesh Singh, Dr. Anup Chaturvedi. My colleagues from KC College, Head Department of Statistics, Dr. Asha Jindal, IQAC Coordinator, Dr. Mulay, Ms. Pratiksha Kadam, Ms. Rane, and all the participants who have joined us today. Wishing you all a very good morning. My best wishes to all of you on this birth anniversary of the pioneer of Indian political economy, the great Indian statistician, Dr. Prasanna Chandra Mahalanobis. On this auspicious occasion, Department of Statistics every year bring about new programs, new ideas, new conclaves, and I wonder with that camaraderie how they are able to achieve this. It has been frozen in my diary this particular day that there has to be something coming up. So every year, 29 June, I know this department will bring about innovative programs for us. We celebrate this day as National Statistics Day, and hence I express my gratitude to the entire team at KC, led by Dr. Jindal and the young members who have joined this year to take this event forward. Dear friends, in the current situation where data has become prior to everything, everyone in this world is eager to know the minute analysis and minute to minute how you're able to analyze and talk about various issues. Predictions, whether you call about weather predictions or mathematical modulations on all the global situations, including predictions on economy, GDP, not leaving behind psychology of people, changes in the environment, climate, data on pollution, and many more are not possible without this wonderful subject named as statistics. Even research, whether we do research in nuclear radiochemistry or any kind of research or biomedical research, cannot be spoken about or cannot be worked without statistics. No research paper you would see in any wonderful journal or good journal with a high impact factor without the statistics. So in short, no field of knowledge can work without this field. It is the most needed science, I would say master science for humanity. In fact, I've been addressing all the students and telling them this is the century of statisticians. So indeed, it's a subject that considers the past, knows the present, and has an ability to predict the future. Celebrating National Statistics Day today, we all have gathered at this 4 days national online conclave entitled Recent Trends in Theory and Applications of Statistics. Dear friends, on behalf of HSNC University, I welcome you all to this intelligent and versatile virtual conclave. Today, we are very fortunate to have amidst us. I wouldn't say today, I would say always, we are very fortunate that we have amidst us our Adi Nayak, Honorable Provost of HSNC University, Trustee, HSNC Board, and the Wizard of Indian Real Estate, Dr. Niranjan Hiranandani, who is always leading us from front on this very path. Sir, I must say that under your ACE guidance, your constant support and motivation, every path of KC College and the university and all the colleges under the board, they lead to the success. A hearty welcome to you, sir, and thank you very much for sharing your precious time in the morning with all of us. Thank you, sir. Friends, we are privileged also to have today amidst us few of the best brains in the arena of statistics in India who will be guiding us in this national conclave with their insights. I greet Mr. Mukesh Jain, who will be joining in short while from now. Heartiest welcome to Mr. Prashant Nair, the director of Nielsen, who will guide us about data exploration and how analytics help human race using this data, but also how our wrong statistical decisions can get dangerous. A warm welcome to Dr. Rajesh Singh. He's Professor, Department of Statistics, Sant Gadge Baba, Amravati University. Wonderful to have you, sir, amidst us today. And he's going to talk about the role of statistics in the development of the country. A warm welcome to Dr. Anup Chaturvedi, Professor and ex-head of Department of Statistics, Allahabad University, who's going to talk about and explain time series and SERIMA modeling. Let me take this opportunity to welcome our resource persons who will be conducting various workshops in next 3 days. I don't know whether they have joined. I would request the team KC to convey my warmest welcome to Dr. Debashish Kundu. I was looking forward to even meet him. He's Professor, Department of Mathematics and Statistics, IIT Kanpur. Dr. Suresh Sharma, Professor, Department of Statistics, Punjab University, Chandigarh. Dr. Santosh Bothe, Professor and Head, Innovative Entrepreneurship Development Center, NMIMS University, Shirpur. Dr. Dharmendra Yadav, who's Nodal Officer at the Center for Health Informatics, CHI, New Delhi, and who will be conducting various workshops and also will be chairing the UG presentation sessions. A warm welcome to Dr. Santosh Gite, without whose support, I don't think we would be able to even bring about the changes in the curriculum at HSNC University. He's Associate Professor, University of Mumbai, and he has accepted to chair the PG sessions, postgraduate technical sessions. So a warm welcome to all the resource persons, all the invited speakers, and my heartiest welcome to all our dear students across India who have joined, and also faculty members, research scholars from various parts of India who will be attending this conclave and participating with their presentations. And also they've accepted to be part of competitions in this conclave. I wish all of you all the very best for your participation in this conclave. My heartiest congratulations once again to Team Statistics of our KC College for organizing such wonderful conclave. Keep up the good work. And I look forward to many more conferences and webinars and student engaging activities from this department. And of course, a great research. Before concluding, dear friends, let us all thank Honorable Provost Dr. Niranjan sir for being with us today this morning. Thank you very much, sir. And thank you all once again and all the dignitaries and for your scholarly presence. Heartiest welcome to one and all. Thank you.
Thank you, ma'am, for your able, encouraging and inspiring words. We are confident about doing better than the best every time because of your unconditional support and motivation. Thank you once again. We are blessed to have amongst us a very enthusiastic and a charming person, motivating mentor, a successful entrepreneur, and the fastest learner, Dr. Niranjan Hiranandani. Sir is the provost of our HSNC University Mumbai, trustee of HSNC Board, co-founder and managing director at Hiranandani Group, president of National Real Estate Development Council, and ex-president of Asokan. I request Niranjan sir to kindly deliver the inaugural address. Over to you, sir.
Thank you very much, Pratiksha, for that introduction. Heartiest congratulations to the entire statisticians of India. I salute all of you for the wonderful work that you all are doing. It's such a proud privilege for me to be here today on the birth anniversary of Professor Mahanobolobolis. And it's wonderful that the importance of statistics are now being recognized by each one of them. Dr. Bagla, congratulations, wonderful program that you have organized under your leadership. I'm really happy that Asha Jindal, my congratulations to you. But from your institution, I just do miss Dr. Dinesh Panjwani, who's also a statistician. And I wish he was also here to speak amongst us. And I think I'm missing him. My entire team and also all our guest speakers over here today, amongst others, Mr. Mukesh Jain, Prashant Naik, Rajesh Singh, Anup Chaturvedi, reputed persons to this program. I'm really happy to be here. Statistics have a positive connotation and a negative connotation because statistics can be used and definitely be misused. Unfortunately, people talk about it in a very negative connotation because when we really put up percentages, many times the relative compare unfounded and people are misled. However, statistics have proved to be very efficient, very useful in so many walks of life that we are seeing, and hence the importance of statistics cannot now be undervalued. During these COVID times, we have the statistics staring at us through the day in newspapers, on TV, every aspect of it in comparison.
Sir is facing some connectivity issues. Sir is joining back in a minute.
Hello, can you hear me?
Yes,
Sir,
sir.
yes, sir. Now? So we can hear you. I think there's internet issues.
Yes.
Can you see me now?
Yes, sir.
Yes.
Okay, thank you.
Yes.
Sorry about that. Sorry about that. That was a call drop. The issue is very clear. every morning you get up and the first thing you see is statistics. What is the COVID statistics of the day? What is it in Mumbai? What is it in Maharashtra? What is it in India? What is it in Delhi? What is the mortality? How many people have been inoculated? What is the benchmark of statistics in America as compared to America? What is it compared to it? How many people were affected in the first wave and the second wave, and now the potential of the third wave? All these are statistically well stated, well organized, well studied, and well presented. We can always argue about it, that the potential that we have talked is right or wrong. And certainly we can be critical of everything that the government does in terms of the inoculation or not doing the inoculations, or doing the oxygen or not doing the oxygen, and how many tons are we short of in the statistic analysis, whether it is 4x short or 1x short or 2x short. But if it is short for me oxygen, I don't care if it is 1x short or 4x short, as long as I get my oxygen and I get my vaccination and I get my bed and I get my medicine. So in reality, for the government to be, and for the people to analyze what is the reality of the day, statistics becomes extremely important. Today, in every field of activity, statistics does a very important role. In the West Bengal government, did you read about Prashant Thakur? His statistical analysis was so perfect that he was able to beat the machinery of the BJP and be able to get Mamata Banerjee back into action. He just said that I worked on the statistics of the day and the political statistics, and we were able to win that. What a statistical thought process took place for people who really rely on those statistics in order to win the elections. Every aspect of life now needs to be studied. Weather forecasting, the cyclone coming into it, what is the intensity of what is going to happen in the next stage? These can be all analyzed by artificial intelligence and the statistics which give data to the weather forecasting system, and then bring about a prediction as to what is going to happen. All these are going to become important future tools that we are going to be able to do. All the ideas and thoughts of artificial intelligence really makes and rules the roost. Companies now work on statistics in a very, very big way. We as a company in real estate have to study whether it is worthwhile advertising in print. Is it worthwhile doing on social media? Is it worthwhile advertising through the web or through other means of advertising in order to make the sales happen? And we collect these statistics to say what has resulted in all. So we will ask the customer as to the basis on which they have actually decided to come to our project and then buy an apartment. All this is statistics, data is collected, and then the expenditure for marketing, etc., is based on the statistics that are available to us as to what is the result that can be done. Similarly, companies and corporates are using statistics in a very wide way. The entire distribution angle taken up by companies like Hindustan Lever or by Amazon or others as to how much capacity they should be storing in various will be based on statistical data that they have collected, and their order from the prime producers is based on lots of statistical data which is there. Insurance companies who are now facing the pandemic and are charging you an insurance, base the entire thing on statistical data of the number of deaths and how much the insurance policy should cost us and the future in terms of what is going to happen. So all these aspects of it have taken an important role for us to understand various aspects of society working. So today, statistics forms the bedrock of information. Properly analyzed can be a tool for improving every aspect and quality of life. Used correctly, used properly, it can be a tool which governments will be able to forecast how they are required to look after, whether it is health and hygiene, whether it's in the direction of development that can be done, and other means of statistical analysis. But the collection of data in terms of people is done in India every 10 years through the census. And this detailed statistical data gives us an idea of how many people are born, how many people are at what age, what is the health and hygiene of various people. And all this becomes extremely important for us in order to work on production, capacities, directions, and the extent to which we need to extend health and hygiene in various sectors which are there today. So I do believe that this important tool, this important subject is being discussed today in a very, very formidable manner. The results, I'm sure, will help us to understand the future of statistics and its utilization in various fields. The field is growing, improving, and going much faster due to aid of computers and other things, which will further help accuracy of statistics, delivery of statistics, and utilization of this in society. So my heartiest best wishes on a wonderful day today to the entire department, to the entire college, to the entire fraternity which is there. And thank you very much for calling me here today to address all of you. Thank you very much and wishing you the very best and looking forward to wonderful, correct, accurate statistics in every field of society brought about by the leadership of statisticians who are there in our country, like all of you, and wishing all the students who have also joined all the best in this field of adventure. Thank you and a good day.
Thank you, sir. Thank you so much.
Thank you, sir, for an enlightening and motivating address. Sir has very lucidly explained the role of statistics played in every possible field. Sir, your words have a magical power which inspires every individual. Thank you so much again for joining us today and making a wonderful beginning of our conclave. Thanks a lot, sir. Ma'am, with your permission and sir, with your permission, shall we begin with the sessions now?
Absolutely. All the best to all.
Thank you so
Please
much.
take it forward. Thank you, sir. Thank you so much for joining this morning.
So we are fortunate to have with us Dr. Rajesh Singh, Professor of Department of Statistics at Sant Gadge Baba University, Amravati University, who will talk about the role of statistics in development of country. Sir has more than 29 years of PG teaching experience and over 25 years of research experience. In his tenure, he has also handled many administrative responsibilities like Member of Senate, In Charge Director of UGC Academic Staff College of Amravati University, and many more. Sir has evaluated PhD theses of students from various universities. He is also nominated as a world scientist. We are very happy to have you with us today. Sir, I request you to deliver your talk. Over to you, sir.
Hello.
Sir.
Can you hear me? Am I audible?
Yes, sir, you are audible and visible.
Yes. So very good morning to one and all. Today, at the outset, I will give my best wishes to all of you on the day of National Statistics Day. Before starting my presentation, I pay my great respect to Professor Mahalanobis and his work. Let me start my presentation. The topic of today's lecture is role of statistics. Just a minute, I will share my screen. Can you see the screen now?
Yes, sir.
Okay. So the theme of today's my lecture is role of statistics in development of country. In fact, as the chairman of your society, Mr. Hiranandani, explained about application of statistics in various fields, and also he explained the its application in election and country development in his business area. So on the similar line, this topic is, and my lecture will be covering all those aspects by which statistics plays a very important role in development of nation. In fact, if you will see how it is applied and how we can apply it, and another point is that how we can use for the betterment of our society, that is the theme of our lecture today. And particularly this lecture is designed or prepared for young students. I hope all the students of BSc may be here, so they can learn the importance of statistics, and also they can take their future in this field. So the first slide which I am showing you, what is statistics? In fact, basic definition of statistics at the very beginning in the first year of undergraduate course you will learn. So the definition is very simple. From dictionary definition, you can say mathematics of the collection, organization, and interpretation, or in simple words, collect, analyze data, and after collection and analyzation, calculate results using a specific design, then draw conclusions. Not only you stop here, but you go ahead and try to make decisions in the face of uncertainty. As you know that statistics deal the problem where uncertainty is there. There is randomness, there is uncertainty. The phenomena is having certain probability of happening, some probability of not happening. In such situations, a statistician decides the future course of action. He decides how to take a action so that the decision will be correct. So this is a very simple definition, and everywhere you can see this definition. This is not so important. Now, why do statistics matter? That is the important point. In fact, when we, as a nation, we talk about nation, so our decision makers, when they plan something or some future activities they plan or decisions about policies they take, at that time something is some facts are very important. So they are the evidence. They particularly consider statistical data, and on the basis of that data they make the policies. So they try to collect the evidence or the ground level situation, and then they decide about the policies and they frame the policies. They help identify needs. What will be the need after 5 years, after 10 years, after 15 years, are immediate. They set goals and then they decide the policies. And while in the process of execution of the policy, they continuously monitor the progress of policy and whether to continue that scheme or to change it in midway. They also can take the decision. So in fact, they monitor the progress of the policy and accordingly they take the decisions. Without good statistics, the development progress is blind. That means if data is fault, then whatever policy will be decided, that will be wrong. And therefore, rather than development, some other thing may happen. The wrong decisions will be taken, and therefore, rather than progress, the loss may also take place. And policy makers cannot learn from their mistakes and redefine new policies. this helps data only. If a policy maker is executing or implementing certain policy, at that time he learn the mistakes, wrong deeds by analyzing the present data or past data and accordingly redefine the policies. Now, why country needs statistics? Purpose of statistics what will be for the development of the nation. So collecting data on subsets of the population and just the role of statistics in national development is very critical. Reliable statistics describe the reality of people's everyday life. By the collection of the data, you get the following informations: timely and complete, accurate data, and reliable also is very important, because if these things, timely data you will not provide or will be collected, complete data, partial data will not serve the purpose. But sometimes sampling methods are there, but we are talking in term of even applying the sampling, complete information will be there. So complete word has a general meaning that completeness is also in case of sample, because the information will be complete and accurate. If wrongly data is collected, then again that will not serve the purpose. And if the data is not reliable, whosoever has collected, he is not has collected properly, then in that case also problem may occur. And why you will collect this data? The purpose will be sustaining an environment which fosters a strong, equitable development. Our aim will be, in case of our nation or country, the development. Whatever we are doing, the purpose is the betterment of the nation. And how the betterment of nation can be achieved? By the progress of society, by the progress of industry, by the progress of education, reduction in poverty. So every step you will take, which will be a positive step toward the progress that serves the purpose of development. So some of the examples I have quoted here, like GDP, inflation rate, poverty, head count, income per capita, labor force, housing and land use planning, schooling, health outcomes, health care planning, providing education facilities, etc. So every dimension of our society development, if you will see, so that must be planned in the positive manner, and the data must be needed for such type of decision making. Now, if you will see, the statistical methods are applied how in the nation's development. So decision making for accurate inferences from arranged data. Decision will be taken only on the basis of a very accurate data. On the basis of data, inferences will be drawn, and on that inference, decisions will be making. Evidence-based policy. Only making the policy will not serve the purpose, but statistical evidence, database evidence will be there. That suppose, for example, you are saying that their development is taking place. So you have to show that, prove that really development is taking place, and that can be done by providing or producing the ground level data, and by proving that, see, these are the evidences and really the progress is being done. Program and projects by putting the best available evidence. So as you see that these evidences or data will be how utilized naturally by making certain scheme or programs, and those scheme and programs will be in the form of projects, and those projects will be implemented. The last point says that policy development and implementation. So once the program or project is defined, decided, then those policy will be implemented. Then only you can see the changes or development in our nation. So some of the examples, this is not limited, just a glimpse. I have put here some examples, but in detail, just I will show you. So as example, I have mentioned here, study the safety of nuclear power plants. This can be done by collecting the data of last 1 year, last 6 months, or 4 year, 1 month, anything, time frame you can decide, but data will be needed that whether there has happened any failure or any unsafety thing has happened. So that type of data will be taken and then that will be analyzed. You are very much aware that nowadays environmental issues are very important. We all are talking about pollution and other things. Just on 5th of June, we have celebrated it also. So evaluate the environmental impact of pollution. If we want to study pollution, if we want to launch a certain scheme, then the environmental impact must be studied, and after studying that, some scheme can be decided by government or world organizations. Determine the effectiveness of new drugs. As you might have heard about the COVID-19 drugs are coming, trial are going on, vaccines are coming. So how these things are developed? Just by studying the effectiveness of any drug, by conducting its clinical trials, and then after getting the result, positive result, only these drugs are floated in the market. So determining the effectiveness of new drugs can be done by using the statistical methods or data. Estimate the unemployment. In fact, anything you can estimate by the past data, and you can do the future prediction. But here, just for sake of simplicity, unemployment rate is taken. So if our government want to plan certain employment scheme, job providing schemes, in that case, what is present unemployment rate? How much portion of a particular group of population is unemployed? By collecting that data, government can decide any scheme. So for that purpose, estimation is needed. Another example is analyzing consumer demand for products. If you will see the company, those produces the items, luxury items are common items, they study the need of the society. After analyzing that need, they start producing the product. So for that purpose, they study the consumer's demand, and accordingly they maintain the supply. So this is also important in particularly for industries and businessmen. And last important is plan and analyze agricultural experiments. As our students study in their, I think in first year in every university, design of experiment. So those experiments are basically for agricultural purpose developed, and such type of study helps to our farmers to stop their suicides and to implement which type of agricultural demand will be there, and how which particular crop will be grown in particular area. So these type of studies are done generally. These are some examples by which statistics plays a very important role. To summarize in simple pictorial presentation, these are all the fields where generally statistics is applied and all leads to the progress of our nation. In the area of business, start from business. In our physical sciences, astronomy, chemistry, physics, environment, agriculture, ecology, forestry, animal populations, government scheme, census, law, national defense, and government, our administrative fields, health and medicine, genetics, clinical trials, epidemiology, and pharmacology. So in broadly, we can define where statistics are used, and by using this way, we come out with the certain conclusions, and accordingly we make the policies. Now let us see the business and industry. As you know that in business or industry, manufacturings are generally done. So what manufacturer only producing does not serve their complete purpose, but marketing and need-based marketing is the important. Otherwise, if they will produce and produce only, but the production will not be sold out, in that case, they will be having a lot of unutilized products and the company will be in loss. So build products and particularly I will say here that quality control is also important for business and industry purpose, which generally you people, our students study in their undergraduate course. So build products and deliver services that satisfy consumers and increase the corporation's profit margin. So this is a simple words presentation, but to explain it, many fields can be defined there. Production, and before production, identifying the raw materials, then study of market, then delivery management. You, our students might have heard or be studying the transportation type of problem in their operation research. So for delivery service, those type of problems are developed, solutions are developed. So transportation problems are applied in delivery services. Consumer, satisfying consumers, you can study need of consumer, and then your product is satisfying their need or not. That can be performed by a survey based study, and you can judge the need whether the consumers are satisfied or not. And if they are not satisfied, in that case certain change can be taken, done, and prediction can also be done here, that how and what changes will satisfy them. And by doing all this, why we will do, ultimately the aim will be to increase the corporation's profit. Our industry must be in profit and they should not face any kind of loss. Marketing, as I explained here you can apply the design of experiment techniques. Launching of new products. Launching of new products means what? If certain problems are noticed in our in the present production by any industry, that this is not serving the purpose, or there are certain lacuna, or society needs some advanced product. So by that study, they can implement and technology and new products that can be launched in the market. Conduct focus groups and sample surveys. For marketing, complete census is not possible. So sample surveys are done, that means limited subjects are studied, and on the basis of that, strategies are drawn, and perform field experiments in test markets to determine product availability. If availability means that if market is having some kind of product already there, then in that case, why to launch the same product? Company can decide another variation or some advanced feature type of product, and then that can be launched. In the case of engineering, here implementing quality control techniques makes many things more improved. Production particularly needs a consistent type of production. That means quality will be constant. What happens when a company produces certain products? So due to continued use of the die, either die damages or die size increases. So such type of problems are detected by statisticians. If raw material is not properly mixed or used, or laborers are doing certain mistakes, that is human error. So all these type of problems are identified by quality control methods, and which can be done by a trained statistician. But nowadays, the engineering curriculum, those are doing their master degree in engineering, they also study this technique, quality control techniques, and most of the places they are implementing. But our statistician can also use this type of work technique and identify the problems in the production and then provide the solution. At least he can bring in the notice of our industries that there is a problem and you must rectify it. So that is one of the application of statistics in engineering. Now, in your mind, their question will be that how the nation will be benefited. Certainly, if good quality production will be there and new innovative products will be in market, certainly that will increase the GDP of our country and also the satisfaction of our public or society. There are many measures by which a country is developed or not defined. So, for example, if a student is taking the admission in a certain graduation course, then a student may think that how he is contributing in the development of nation. But my dear friends, you are really contributing in the development of nation by taking simply admission and passing your degree exam. Being graduate, you are contributing in the development of nation. By your graduation, the education rate will increase. That means educated population of our country will increase, and moreover, gross enrollment ratio will also increase, GER, for which our country is giving weight that GER should be high. At present, we are at very low level compared to other European and American countries, developed countries rather, I will say. Their GER is about 80 and onwards, but our is around 30. We are trying to increase it. So if students are attending classes, taking admission and getting the degree, that also contributes. So statistical computing, particularly in software area, statistics is very important. Statistics contributes. So in software design and development, testing, quality assurance, technical support, marketing and sales, to develop code that is both user-friendly and sufficiently complex, reliability assessment of softwares. So these are the areas where a statistician can play important role, and therefore he can contribute in the GDP. Now another area is health and medicine. So in this area also, statistics plays important role, and therefore the growth of nation take place. So work on calculating cancer incidences rates, monitor disease, outbreaks of certain disease, and monitor changes in the health related behavior such as smoking, physical activity, rate of change of certain disease, increase in certain disease. These are the areas where data are collected and then analyzed. And on the basis of that, our decision makers frame the policy. Now, public health is another issue that prevent disease. Nowadays, I think everyone must be familiar, particularly this topic, because our country, our whole world is fighting with the COVID, and therefore this topic or this particular area has become very important. So prevent disease, prolong life, and promote health through organized community efforts, including sanitizing, hygiene, education, diagnosis, and preventative treatment. Another area is pharmacology, where scientists develop certain type of drugs, they get the approval and then marketing to ensure the validity and accurate of finding at all stages of process. So in particularly pharma industry, you might be noticing that many kind of drugs are available for various diseases. So they are having certain advantages, certain disadvantages. There are certain drawbacks, certain merits. So which drug is more effective, that we find by applying the statistical techniques. And doctors also get the result from the company or from third party, and then they prescribe the medicines. So such type of study is also very important. Next hour is genetics. Now this area is very popular, particularly by interdisciplinary research. Statisticians and genetics researchers are coming together and they are doing some sort of joint work, and particularly analysis due to availability of very fast computers, advanced computers, the coding and other things has become easy, though they are very complicated. But due to certain softwares, our statisticians are doing very good work in this area. They are doing very nicely the modeling of certain genomes and then their study. So label possible indicators of genetic abnormalities such as birth defects, early aging, predesirable characteristics in plant offspring, etc. And these are all things are being done by this coding of genes and then statistical analysis and then further their modeling. And then learning, education sector also utilizes the statistics and contribute in the development of nation. So the very simple thing is that, as I earlier said, by education means giving the knowledge of statistics, what we produce as graduates, postgraduates, students, and researchers and teachers. Researchers particularly and teachers contribute a lot for the welfare of society. Researchers do research and give new innovative ideas, innovative things, and teachers develop the good human being, good human resources for the development of nation. Effectiveness are develop statistical models to present student learning. So if statistics is clear, the knowledge of statistics is to our students or teachers, then they can do teaching in a very effective manner. They can develop good statistical models and present the material to their students or society in a very appropriate manner. This is another area where science, writing, and journalism, you may be knowing that nowadays in every research, either it is in sociology, psychology, or in science subjects, statistical analysis is essential. Without the statistical data support or justification, no work is accepted. I have helped many researchers. So from my experience, I can tell you that whenever any researcher submit a research project or research paper, then first thing is the examiner see whether he has used statistical methods or not. He has applied certain statistical testing methods or not. Without that, because you are proving whatever you are saying by your data support. So in that field, that statistics has become very important, and work with mass media, universities and corporations to produce news briefs, articles, news release and other reports. So everywhere statistics plays important role. Now government work, government also do many kind of research for making the policy, as many times I repeated. So for bringing any regulations, for making any guidelines or bringing any GR, government study the present are also past, and then accordingly they frame the rule. So as an example, stock trading, if you will see, so if government is framing any regulation, then certainly they have studied the past data. And by the way, I would like to add here also that stock trading is a business which is totally now based on the statistical analysis. If they have developed very complicated and advanced softwares for study of the data of stock values, and accordingly they predict the next day market, and then they sell or purchase the shares. So in the field of pollution, if government is making any decision, policy, then certainly they apply statistical methods. Drug approvals, if government is certifying any medicines that this is useful or this is having no side effect, issuing any guidelines, then they have in their back the study of the data. Either they themselves conduct the study or they take the help of third party, and then they frame the guidelines. Testify in court proceedings. Generally, you might be knowing that in court that decisions are taken on the basis of evidences. So evidence doesn't mean only then that the person is testifying in the court. There are many cases which are decided on the basis of data-based proofs. That means if data is produced there, certain documents are produced there, then also decisions are taken by judges and they pass the order. So there also they justify the use of statistics. I will tell you one of the very important I think example, you know that in our country, the judicial system was jury based. I think you may be knowing jury means 10 or 15, that depends on the government decision. Number of persons sits and collective they take the decision. Jury system is still, I think, in European country, but in our country, the government has stopped here. One bench, two bench, three bench judges are there. So jury based means juries where they were not the expert of law, they were some person, that means the juries, the group of juries were experts from different fields, like educated, businessman, industrialist, means that the government were framing the experts of various fields, and that they called as jury. That were the system in our earlier days. By statistical study, it was noticed that that decision making is having certain lacuna. Therefore, after independence, 10 or 15 years, our government stopped that jury system, and then judges system came. But my purpose of telling you is that the study was based on statistics only, so that government could take the decision to stop that jury system of making the judgment. Now, congressional hearings and lobbying arguments, these are where fields where government make policies, and everywhere the application of statistical methods are there, statistical data is there, and then they make the decision. As you know, in research, it is always difficult to collect the complete data. Census of every study is not possible. So we apply the survey method. And P.C. Mahalanobis has contributed a lot in this field. In fact, at the end, 4 or 5 slides I have prepared, which will show you the contribution of P.C. Mahalanobis in the area of statistics, that I will discuss at the end, because the theme of my today's lecture is role of statistics in the development of country. So initial slides are based on that theme only, but at the end I will tell you the contribution of our Professor P.C. Mahalanobis. So this is the survey methods which is always applied in research. And here, you know that data is collected by sampling, applying a very appropriate sampling method. There are various type of sampling methods. That is a different issue and different topic for lecture. But in social sciences or any study, complete data study is not possible. So we go for samples. In the field of education, in the field of law, that certain policy if you want to make, and then for making that policy, you collect the data for that area using a survey method. Forestry, agriculture, biology, medicine, business, e-commerce, any field you name, their study is done and their survey methods are applied. I can say that everywhere, wherever study is done, survey methods of is applied and sampling is used there. Social statistics, we will see that in the court, including DNA evidences, salary discrepancies, discrimination, lawsuits, and disease clusters, court decides on the basis of rules, legal instruments, earlier framed laws, and plus the data. Data is needed there also in making the decisions. Consulting That means work on a temporary basis on a variety of projects, including quality improvement, pharmaceuticals, ecology, and engineering. If you want to appoint certain consultant for a particular project, then certainly you want to hire some temporary employees or some consultants. So for that, you take the help of statistics, analyze the volume of your data, and then you decide. Another area is natural resources like agriculture. You know that our government uh, uh, always forecast that this year wheat production will be this much, this year rice production will be this much. How they do? On the basis of applying sampling methods and collecting the data, they do this type of predictions. So in the field of agriculture, if you will see the research side, then chemical pesticide which will be used or not, whether their effect of is good or bad, this type of study is done by using the data analysis method. Hydrogeology is area, veterinary science, genetics, crop management, optimal yield. That means the crop which will be produced, what will be future requirement, then government help farmer to take this type of crop this year and this much area. So these type of decisions of government are taken by applying statistics. Even farmers can use statistical methods for their producing crop problems. Ecology. Ecology is another area where statistics plays a very important role in the development of our country. You might be hearing the ecological problems, ecology imbalance, these type of things. So how that is analyzed by this method only, applying statistical technique. Address questions about the Earth's natural environment, including animal populations. We are seeing that tigers of our country is eliminating, and we are running the tiger projects. How we are knowing that? By studying the data of tigers. There is a sampling method, capture recapture sampling technique, by which we study the number of existing tigers, and then accordingly we decide the policies. So not only for tiger, there are many areas where such type of animal population study is needed, and their statistics plays a very important role. So agricultural products protections and fertilizer and pesticide safety, these type of problems are dealt by statistical methods. So these are all the areas where by applying statistical techniques, we can, or a statistician can contribute in the development of nation, and our country can go ahead. Many statisticians are presently playing important role, or earlier played important role. So one of them is Professor P.C. Mahalanobis. You all may be knowing about him, and we are celebrating National Statistics Day. I think around 18 years back, when Prime Minister Manmohan Singh was the PM, at that time, he declared this day, 29th June, as a National Statistics Day to remember PC Mahalanobis and to what we can say, his contributions of PC Mahalanobis to identify his contributions. That 29 June and various activities were started on today's day. In fact, central government started some quiz competitions, essay competition to promote concept of statistics among our students, and they are giving the prize at the hands of our Prime Minister. Every year this is celebrated, and in the I think Science Bhavan, Vigyan Bhavan, they conduct this type of ceremony. One of my student has also received the prize for essay competition. So many things Professor Mahalanobis have contributed, and some of the important things I am presenting here. But by this only you cannot understand that the application of his contribution. It is just a brief idea, but if you will think that the application of his methods in the solving the problem of society, then that is so important that our development, country's development, I can say that many things is possible due to his contributions only. So mainly he is known for Mahalanobis distance, a statistical measure. Mahalanobis distance in the multivariate topic we teach our students, that measures the difference between a fixed value and the data set of value. What is the difference between the two set of variables that we measure by Mahalanobis distance? This he developed while studying the economical data, because you know that our target value is this much, some fixed value is our target value, but after any scheme, or you can say our present value of those characteristics are this much. So how much that differs? You cannot measure by taking the difference of one value to a standard value. And when you are having a set of observation for every characteristic, 1,000, 10,000 sample values observation. So this method he has given to measure, and by this only our economical decision making has changed a lot, and all the policies are being framed by applying this distance technique, this measure of distance, measuring and then making the policy. So whatever economical decisions or economical study or society study is taking place, that is only because Mahalanobis has given the distance. We, as a statistics student, only understand what is this measure, and we solve some one or two problem of multivariate by measuring Mahalanobis distance. But in at grassroots level, the application of this distance, measure of distance, is too much, that government is applying at every stage this measure and then making the policy. So you can understand the application of that Mahalanobis distance. He has also measurements in the anthropology study and given some sort of measures there. Anthropology, you may be knowing that that taking the measure of, suppose, length of nose, width of eyes, forehead width, and then our study body structure, length of hands, these type of, and how one particular race is different from other race, how one particular religion people are different from other place. Such type of studies he has done in particularly uh, near about Calcutta area. That very popular research paper is published, his contribution in the Journal of Indian Calcutta Statistical, if I am right, then there it is published. So such type of human study, the differentiation of races, he has done, means new concept he has given. This is again a multivariate topic, and here he has defined new measures and many society-based problem he has solved. He means his team complete. He was certainly the chairman, but he has given the idea, and those type of problems are solved. And as you know that Professor Mahalanobis was the planning commission member, first planning commission, 5-year plans, which we were used to say 5-year plan, first 5-year, second 5-year, up to 12th 5-year plan our country has made. Nowadays we are making year to year planning. Government has stopped that 5-year planning, but the idea of 5-year planning was PC Mahalanobis, because he was one of the member of planning commission, first planning commission. Then he realized that if we are making a certain plan and trying to implement that in such a big country every year, so that is not possible. Only making the plan and giving message of that plan to the public, making aware to our public or users, 1 year will pass. So when that plan will be implemented, so Mahalanobis, Professor Mahalanobis decided or taken a decision that 1 year will be, suppose, spreading the message of plan, making aware the public. Then second year will be making the strategy for that, and 3 year, 2 year, that plan can be, or certain government policy can be implemented. So 5-year plan, he decided that every plan will be 5 years, and during that plan will be implemented. And in the second 5-year plan, the earlier will be assessed, and accordingly the changes will take place. And nowadays 1 year planning we are doing, and in my personal opinion that we are facing a lot of problem. So he was the pioneer of that 5-year planning system, and during that period, whatever study was needed for making the decision, so he designed large scale sample surveys, particularly these type of problems. Consumer expenditure, tea, because Darjeeling area near about Calcutta, tea is produced and consumed, but it is consumed all over India, but mainly produced near about Calcutta, that means Assam and Bengal. So tea problem, tea drinking habits, tea production, these type of study by applying sample methods, his team and has conducted. Public opinion type of studies he has done. Crop producing, land and plant diseases, etc. So all these type of studies he has done. When I am saying he has done, that means he has developed the planning of that study. He has developed the structure of study. He has developed, if suppose opinion, then questionnaire of that study, and you all can understand that starting a work is very difficult. improvement can be done by anybody noticing the problem, but pioneering a certain idea is very, very difficult. And you can see that Professor Mahalanobis has started so many type of sampling surveys, and this is only limited which I could find. There are many things which he has done for the government 5-year planning purposes. So this is a very important area where he has contributed crop yield estimation. That means whatever we are today seeing the government forecasting that wheat will be this much quintal or rice will be this much, the whole concept was developed by Professor Mahalanobis. He is the pioneer of these type of concepts, and then he implemented many years. Now we are continuing those concepts in present date also. He started research in the field of quantitative linguistics. This is very less people know that Professor Mahalanobis has also worked on this area. These two areas, some, as you know that Professor Mahalanobis, I will tell you, Professor Mahalanobis started ISI, Indian Statistical Institute in Calcutta, and that is initially was based for statistics only, but later on he expanded and many branches were added there. So one of the department or branch you can say is linguistic there. So with the help of professors of language science and making a team, he studied in the field of quantitative linguistics and language planning to solve the problem of this language corrections. The language correction field is there. Speech pathology, we can say. In this area also, he contributed by doing the research, by guiding the professor of those particular area, making a team, and he studied the data related to that, and then suggested new methods for the correction of language, and we say that speech pathology. In this area also he has contributed. So this is the development of Feldman-Mahalanobis model of economic development used in second 5-year plan, which promoted rapid industrialization. As I earlier explained you, that his model and his distance, measure of distance, Mahalanobis, was implemented in the 5-year plan, second particularly 5-year plan, and after that in India, rapidly industrialization taken place. So second and third onwards, earlier you know that our country was only agriculture based country and very less industry were there. So after that, after those type of findings, research, he guided to our government and industrialists that this type of productions are needed, this type of products are needed to our society, and then industrialization taken place. So these are the very important contribution of Professor Mahalanobis. As you know that how he could do this, because he was the member of first, second, third Planning Commission of India, 1955 to 1967, if I am right. Then he was the member of Planning Commission, and many times he chaired also the commission. And whole concept of 5-year plan was Professor. He was very respected by first Prime Minister Sri Jawaharlal Nehru ji. He was very close to him, and because of his contribution, Jawaharlal Nehru was having high regard for him. And the main contribution, you can say, that he started Indian Statistical Institute, Calcutta in 1932. This is because whatever development in statistics you are saying, many of those are coming from ISI Calcutta. And 1932, you can see, if he was basically, Professor Mahalanobis was a physicist. His biography you can see from net, or I think other speaker will give you detail of his personal biography. I have not covered those topics because my theme of the lecture was role of statistics in contribution in the development of country. That was the topic. So I have covered that area only. This is all about I wanted to tell you. And remember that there is strength in numbers. So numbers plays a very important role. This much I wanted to present. I think time is almost over. 1 hour.
Are there any questions from the audience? If you have any questions, you can type your questions in the chat box. We can take few questions. Sir, is it okay? Can we take few questions?
Yeah, you can, the students can ask some questions.
Yes,
I
if
am
the
trying
participants
to.
have any questions, you can drop your questions in the chat box. We'll take your questions.
They can also start their mic and
Yes,
ask
you can unmute
questions.
yourself and speak. So, Ashan, shall we go ahead?
Yes, Pratiksha, I think so. Sir has said everything clearly, so no questions are there. We can go ahead. He was very specific, so students may be clear with everything.
Yes.
Yeah.
Thank you so much, sir, for your inputs about the role of statistics in the development of our nation. And you have thrown a light on the contribution of PC Mahalanobis. Thank you once again for joining us and enlightening us on this topic. Thank you, sir.
Thank you very much. Thank you.
So we are very fortunate to have with us Mr. Prashant Nair, who is the director of Nielsen, and who will guide us about the data exploration, how analytics help human race using this data, but also how we are wrong how wrong statistical decisions can be dangerous. Mr. Prashant is an analytical professional with close to 15 years of experience. He has sound knowledge of statistical theory and applications. Also, Sir has working experience of client service, statistical and data modeling with analytics. He has globally led the team of statisticians providing modeling and consulting on structural equation modeling. The key responsibilities which he has handled in his career also include managing relationships with the global vendor who provides standard analysis to various client teams and also the diagnostic consulting. We are lucky to have you with us today. I request Prashant Nair sir to deliver his session. Over to sir.
Thank you very much, Pratiksha ma'am. Am I audible?
Yes, you're audible.
Okay, so should I share my screen, or will either you or Suraj will be sharing
If
this?
you want, I can share the screen. Should I?
Yeah, I mean, that will be helpful, just to be sure that, there's no break.
Okay,
I'm
okay.
experiencing some network issue at my end, therefore I'll keep my
All right.
video off. Yeah. Okay,
All
so
right.
ma'am, while you share your screen, a bit of a context setting, right? So first and foremost, good morning to all students, faculties, teachers, all madam and professors. It's a great honor for me to be here, to be a part of this and share my experience and some of my learnings, working in the industry using statistics, right? Needless to say, I was like you, I was a student. I've been through this journey, and gives me great excitement and great energy to sort of to talk about how this subject has been close to my heart. Obviously it has been close to my heart. That's the reason I've kind of picked it up. When Asha ma'am checked with me if I'll be able to take a session, I said that yes, absolutely. The only question was, what is it that I should be talking about? Because I know, with so many professors, so many teachers around who are the masters and the real statisticians, right? It's a little overwhelming for me to really speak. And we all heard Dr. Rajesh talk about so many applications of statistics, right? So yeah, but what I'll definitely try to do in the next 40-45 minutes is really give my perspective about statistics and how it has evolved over the past a few years, and a twist to what what you will be seeing now here is that I'm not really going to touch upon the theoretical part of it, rather more application, and within application also a very pragmatic perspective, that when I look back at my career, when I see that how I have used statistics and interpretation, what is it that I could do better, right? And that's the reason, if you really see on the screen, the topic that I want to really talk about is not about how you use analytics or statistics in your daily work, but actually going beyond that and realizing that all of us individually have a bigger responsibility towards our society, towards the world, when we attempt to use statistics, and which is this social side, which is the humane side of statistics. And this may sound funny to a few of you, because you may say that, well, statistics is a subject, how can it have a humane side? But that's the interesting part of it, and let me see if I'm able to convince all of you, to really look at statistics through this lens, right? Once again, I would, before I kind of begin, a big congratulations to the organizing committee, Asha ma'am, Pratiksha ma'am, all of you, Hema ma'am, to make this conclave happen. It is indeed a big achievement, I would say, right? Okay, so with that, I kind of, begin, right? So as I said, when I thought about, how best can we use statistics in real life, well, there are hundreds and hundreds of ways one could use, yeah, right? And often what happens is that, because it is available in abundance, you use a software, you go to the internet, you use a statistical software, everything is easily available, because of which often we tend to take it for granted, and we miss out on the important aspect of how not understanding statistics well, and therefore using it in a wrong way or making a wrong decisions could have a far reaching impact on our life, on our environment, and the rest of the world, right? And I believe that this is much bigger. It's more like a type 1 and type 2 error, right? I mean, whether you do something incorrectly versus doing something correctly, which is not entirely accurate, and those perspectives, right? Pratiksha ma'am, if you can move to the next slide, please. Yeah. To give you a little bit of a philosophical perspective, right? We all are humans, right? And we all know the various footprints that we have our environment. Interesting that the left-hand side of this slide that you see is what we call as a carbon footprint. Each one of us know, when we use our gadgets, when we use our mobile phones or television, you say whatever, everything has a carbon emission, right? I mean, when we drive in a vehicle, when we take a particular Uber or a Ola to a particular destination, what is happening is really there is carbon emission, and this is no news to you. I mean, all of you know, and it has been around for quite some time. And the good thing is that, because of such a big awareness of carbon footprints and its adverse impact on the environment, there are already measures taken to address it. which means that there is a problem. Yes, there is a problem which is around carbon footprint, but there is also far-reaching solutions that are really coming into picture, right? And as I mentioned, carbon emissions are really resulting from a personal lifestyle choices. So, for example, to give a very plain, simple example, right? I can carry probably say 3 to 5 mobile phones, right? Now, carrying 3 to 5 mobile phones versus carrying one mobile phone, obviously it has a varying impact on the carbon emission, right? Now, as I said, the good thing is that we all realize there's a problem, and there is already a lot of measures taken to address it. You look at the global treaties between all the prime ministers of the various countries that they are signing, they all are very, very conscious about it. The floods, the earthquakes, the volcanoes, everything has gone up massively, and that is only because of the increasingly carbon footprint, which is creating a havoc with the environment, right? Now, if we were to sort of park this aside for the moment, there is another interesting footprint that we all are creating, right? And which is what the right-hand side of the slide talks about, which is the data footprint, right? And why do I call it as data footprint? Because the amount of data that is getting generated through each one of us, through each step we take in our lifestyle, in a day-to-day lifestyle, it is massive. For example, right, when you go to a food bazaar, when you go to a restaurant, right, when you swipe your card, when you make certain purchases, all of these things are getting recorded digitally. What are these? Where is it getting stored? All these are getting stored in what we call as the data lakes or bigger servers, and those kind of systems, right? And this is precisely what I'm referring to, data footprint, right? You will realize the extent of data that we are creating, that we are unknowingly creating. Next slide, please. Yeah, okay. So, our data footprints, right? I mean, you will be surprised to know that, it is almost boundless, right? What you see on the graph is a pictorial representation of how from say 1985 to at this moment and going forward, how the amount of data that is getting generated is increasing exponentially, right? And if you really visualize the curve, it's an exponential curve, right? And at this juncture, which is the extreme right hand side point of the chart, right, we are in a bubble which is ready to explode, right? Because we take about artificial intelligence, we take about predictive analytics, we take about automated driven cars, we talk about smart cities, we everything is getting connected with each other, right? You talk about the internet of things, right? Well, yes, absolutely, these are good things, these are making human lives far, far better. But on the flip side, what is unfortunately also happening is that it is creating hell lot of data. It is creating a lot and lot of data, which is and every single organization is trying their bit to kind of store this data so that they can use this data to analyze, to give back to the customers in terms of what can be done and things like that, right? So this is just a representation in terms of how much we are creating the data, and it is almost boundless, right? Next slide, please. Right. So where are we heading? Right now, this is an interesting chart, right? It simply gives you two data points, which is 210 in time on time point and 230. And what we are talking about is by 2030, we are going to almost see an exponential increase in data, which is nearly 78 yottabyte. And for all of your information, 1 yottabyte is equals to 10 raised to 24 units of data. And again, to make it a little bit more simpler to understand, right, this is equivalent to one massive room which is stored of almost like 4 to 5 square kilometer data. It's just unimaginable. While researchers and scientists have been able to put a measure to it, technically speaking, it is nearly impossible to measure it, right? So and as I called out, the simplest way to look at it is a sea of data, and we don't know what is going to happen. We are kind of just going on creating unknowingly, knowingly, right? And that's where what the world really needs is help, right? You can it's almost like the world is sinking into the sea of big data without all of us realizing. Now, having said this, of course, my intention is not to present a gloomy picture. My intention is not to make you all feel disappointed, all feel sad, but I want to really touch upon the fact that we are gradually getting into swimming into the sea of data, right? Now, having said this, right, ma'am, if you can go to next slide, please. Yes. How are we helping the world? Now, this is a bit going to touch about what Rajesh sir also spoke about. Now, when we say that there is so much of data that is getting created, is it so bad? Well, not really, because as human minds, we always keep looking for innovation, invention, right? So we always keep looking for ways to see that how we can use this big data. So there are multiple ways and multiple approaches that has already been taken to utilize this big data. For example, to start with, when we talk about agricultural productivity, right? Using analytics, using statistics at this point of time, farmers have the ability to already identify those crops which are going to get infected by a virus. So which means that in the next few days they will be able to identify that this part of their farming, this part of their productivity is going to be severely impacted. Therefore they need to immediately get some sort of a pesticide. They need to treat the crops immediately, which means that it is going to save them a whole lot of money, right? Otherwise, if the farming cultivation that they have done, that is going to be completely infested by a virus, it's such a total waste, not only for the farmers but also for the larger economy, right? Moving to healthcare, right? In today's world, right? If you look at healthcare, you go to any of the major hospitals, you see a lot of digital data being used. They're able to send SMS to patients relatives, saying that, okay, this is your report, this is your blood report, this is where the problem is, and this is what you need to do next. When you go to an x-ray room, when you go ahead to do a sonography, all of these are technology driven, and all of this also generates a lot of data. And in hindsight, what is really happening is that it is improving human life. It is improving the quality of human life. So which means that today, if I have a disease, I have the chance, I have the possibility to get it treated by a doctor, and my life expectancy, right, which is merely saying that, how long will I survive, that is going up, right? So obviously data is helping there. Come to the bottom of this slide. If you look at the wind farms, right, these are natural sources of electricity generation, right? And with the use of data in statistics, the right locations can be identified, because if you don't choose the right locations, there is millions and millions of money that is getting invested to set up the wind farms. And if it is not the location where you're going to see a lot of wind, obviously it's going to be a total waste of money, right? And moving on, when we talk about productivity manufacturing unit, there's a lot that is getting efficiently done, right? Statistical quality control, which uses statistics. It is able to tell you that if you're generating, say, 1,000 units of a product, right, which of the product, what is the confidence interval that the product are of top quality. So there's a lot, obviously, and all these things is happening only because we have a lot of data, we have statistics, and this is how we kind of helping the world. And a few more to look at. If we move to the next slide, please. Right. And as I said, some more positives, right? Supply chain. Now, what is the supply chain, right? I mean, in today's world, we all would have used e-commerce, e-shopping, Amazon shopping, some way or the other, right? Amazon, Flipkart, you name it, there are so many e-commerce sites. And, especially with the lockdown in and everything, the e-commerce companies have become a big boon for all of us as customers, right? So even in this, right, in order to identify that, which are the areas which are under lockdown, and therefore courier delivery is not allowed, versus which are the areas which has, a high reach, high affluent population where the rich people are living, or say, for example, where there are affluent people living, all this can be ascertained with the use of statistics and analytics, right? To the right hand side, what you see, we all would have used Uber and Ola at some point of time, right? How do they know? How are you able to book those cabs, right? Because you're using your GPS coordinates, right? And that is nothing but what we call as geospatial analytics, right? So in a nutshell, you're able to do so many things. There are so many different benefits that you get using this massive sea of data, using statistics and analytics, right? And at the end of all this, you, me, as customers, we all are satisfied, we all are happy, and we keep looking out for more and more important things. And that's how the organizations are also trying to help us, right? Ma'am, next slide, please. So as I said, customer satisfaction is the bottom line, right? Because if you're not happy with something, with the product that you have ordered through Amazon, obviously you have the policy of returning it back, right? So Amazon takes your feedback. Amazon understands that, okay, what is it that you didn't like in the product? They will take your feedback. They will implement it in the product. And next time when you order something, they have your address and your name, and therefore they know that this particular customer was not satisfied with my product the last time, right? So there are obviously tons and tons of benefits, right? However, right, as you see on this slide, this is just a drop in the ocean. What do I mean by that, right? There are so many things that we have seen. Look at this graph, right? Now, this is an interesting graph that you would see. The orange line shows how the shows how the growth rate of data is moving, right? At the same time, the blue line, which is really tapering downwards, that is how the analyst population is growing. And when I'm saying analyst population, it's me, it's you, it's all of us, right? With data, so much of data getting generated, right? Who is going to study it? Who is going to analyze it? How are people going to make sense of it? Because the bigger companies, because the government, they need people who know statistics, who have studied statistics, to be able to make sense of this data, right? Unfortunately, if you keep your focus on your top chart, right, what we are seeing is that there is a huge gap in the growth of data versus the growth of the analyst population. What it merely means is that students or population, part of the population, right, who are learning, who are studying statistics and are being able to take this learning to the industry, there exists a huge gap. Now, this is an interesting piece because this also automatically translates to employment. It translates to a lot of job opportunities, and this is something that you all should be extremely happy about, right? Because I'm sure each one of you would have this question in your mind that, okay, you have joined the course, you have joined this conclave, but 2 years after you would have completing this course, when you come out of the course, what is the industry going to look like? Where are you going to get a job? And I'm very sure equally concerned are our faculties, are our professors, saying that they would definitely want the students to be employed, right? So this gap in terms of growth rate of the data versus the analyst population is something that we have to be cognizant of, is something that we have to be aware of. Therefore, we take the subject very seriously, right? And if you see at the bottom, right, this is a simple, indication of how widespread is statistics and analytics in general getting. So while all of us are in some way related to the statistics through course, through academics, there is a big chunk of the population, by the way, who have not studied statistics, who have not gone through the rigors of statistics, but they are already related to the field. Either they would have done some free online courses, either they would have learned through experience, on the job training and everything. So in general, people searching for analytics, searching for statistics, knowledge in the internet, in the public domain is huge, is massive. And in the last few years, last about 10 odd years, I would say this has been crazily growing. And therefore, now, because there is a directional growth, and also there is a sort of a lack of directional growth, so, right? All of us have some of the other directions. You all are very fortunate and very lucky to have such great teachers and faculties who are giving you direction, who are telling you that what is it that is important in statistics to be learned, and what is it that you should be looking at. And however, as I said, there's a great deal of population who have not taken this approach. Rather, they have taken the approach of self-learning, and that is the reason. If you look at the next slide, right, it's a simple pictorial representation of the variety of words, of terminologies related to statistics and data that has come now into the world, right? Ma'am, next slide, please. And it's a simple representation, as you say that you talk about data science, artificial intelligence, machine learning, cloud computing, Internet of Things, big data, what not, blockchain. There are just tons and tons of words that are coming, and this is not all, right? There are still so many more words and so many more terminologies that are coming. And let's be very honest, right? Not everybody who are in this field understand these words to the root. And well, that is where my bigger concern and my bigger point is that while this is a total revolution that is taking place, it's like saying that you all would have heard about the green revolution, right? It's like that itself that is happening. So right now we have what we call as a data revolution. Now, interestingly, my take out here is that, while it's a revolution, it is also an evolution that is happening, right? I mean, and you all must be thinking that what is the difference in that? The difference is that, see, revolution in itself is largely uncontrolled, whereas evolution in itself is a lot more controlled. And I'll touch upon this a little more in the next few slides. Pratiksha ma'am, if you can go to the next slide. Yeah. Okay. Yeah. Please go ahead, ma'am, if you can. Right. But now, to me, right, I'm sure as student, you all must be thinking that, okay, sir, enough of philosophy, enough of lecture. Can you explain us? Can you tell us in this important day that how can we improve our life? How can we increase our chances of getting a job, or how can we increase our chances of getting employed in this industry? Right. So I picked up 4 specific questions that if I were in your place as a student, these questions would occur to me as well, right? So the first question that you may have here after hearing whatever I spoken about is, can I skip it? Can I choose to not be a part of this digital revolution? Can I choose to not be a part of this data revolution and the data explosion that is happening? My answer to that is, you cannot skip it, right? Because you are part of the creator, right? So when you go to a restaurant, when you go to a big bazaar, or any of the malls, right, or for that matter, you use perhaps a good chunk of your day-to-day time you're spending on your mobiles. So when you're accessing any app, when you access Facebook or WhatsApp, technically you are generating the data, so you cannot skip it. As part of today's world, as part of this environment, you are contributing to generating the data. So therefore, what is in it for you? To me, that's the next natural questions, right? So you will say that, okay, I'm contributing to data creation, so what should I do, right? So the question, or rather the perspective that I have over here is that you have a choice whether you want to simply contribute to creating this abundance of data, or whether you also want to contribute in making value from this data, right? There is a reason why you perhaps chose uh, a field in academics which is related to statistics. And one of the fundamental reason, according to me, is that you may be liking numbers. You may be having a positive inclination towards numbers and interpretation, right? So you have a choice whether you merely create the data, or whether you create the data, which is obviously not, it's going to happen, but you also be able to contribute by adding value in terms of insights, in terms of interpretation, in terms of helping the organizations and the government make value from it, right? And that is where your contribution becomes a lot more profound, right? Now, okay, now suppose you agree that yes, I agree to contribute, and that's the reason I've consciously chosen to be part of this conclave. I've chosen to be part of this subject field. What should be my starting point? Because as there is explosion of data with the internet available everywhere, the flip side to that is that often there is confusion. I do not know where should I start. Should I start reading and understanding mean, standard deviation, coefficient of variation, or should I start talking about, say, regression, or should I start talking about, say, artificial intelligence, right? Because it's but natural that when I get into a job, nobody's going to perhaps ask me to take a pen and paper and write down the formula of mean and standard deviation. Neither will I be asked to sort of solve a regression equation, right? So the starting point, according to me, is often a concern. And I come to this conclusion because whenever I interact with students from different universities, I do see a genuine confusion that what should I start? Should I should I search the internet for some very basic statistics? Should I reach out to my professor, my madam, to asking some very basic questions, or what is it, right? So that is where I think, to me, I have an advice, as a friendly advice, obviously. And that's where my suggestion is that you should make sure that your fundamentals and your basics are absolutely clear and strong. So if you move to the next slide, please, Pratiksha ma'am. Right. To me, the starting point, right? I mean, again, I don't want to get into the theoretical definition of analytics of statistics, but what you see on the screen, right? The definition of learning analytics, to me, it sounded very interesting. What it says is that it is about collecting traces that learners leave behind and using those traces to improve learning, right? So our professors, our faculties, our teachers have invested a lot of time learning and doing research, doing theses and everything. So for us as students, for us as the future, we don't need to start from scratch. Rather, what we can do is that we can take the learning from our teachers, from our faculties, and build on those learning. This is not to say that you should totally ignore, say, mean, standard deviation, some of the fundamentals. Rather, what I mean to say is that there is so much of help and support that is available in our immediate environment, that that is what you should start utilizing. That is what you should kind of start building on. For example, right, one of the often seen scenario across everywhere, and I'm sure most of you will also come across the scenario, is that when you get into the any kind of corporate environment, any kind of teaching or any kind of job, right, one of the fundamental question that comes is that who knows p value, right? And what you see on the screen is that pretty much everybody understands p-value. Everybody knows p-value, right? Because we all have gone through the rigors of learning statistics. Our teachers have made us understand that they have spent valuable time. However, the next question, who can explain p-value? When this question comes up, right? Let's be honest, right? And I'll be very open, I'll be very transparent, because we don't need to be ashamed of each other, right? I mean, honesty is very important, right? Most of us tend to take a backseat, right? Because while we may know the theoretical definition of p-value, putting it in a context that a simple non-technical person will understand, say for example the CEO of a company, or for example a person who's not from the statistics background can understand, is where the challenge comes in picture, right? And this is what I want to emphasize a lot on for to all of you, that the starting point has to be as simple as understanding and putting the concepts in a very very practical manner. For example, right, think about how would you define confidence interval in your day-to-day life? Say for example, when you step out of your house to take the vaccination, right? Or when you step out of the house to sort of take a walk in the in the evening, right? What is the what is the error margin? What is the confidence that you have if it is going to rain? Try to link each of the concept, a lot of the concept, to your daily life, and trust me, as I'm saying, I'm kind of talking out here more as a friend, as a peer. It helps massively, and this is exactly what I have personally done. A lot of the quite of the few concepts, things around time series particularly, I got to make a lot of sense when I started implementing it, when I started looking at it from a very very pragmatic perspective, right? Next slide please, ma'am. Right. So a very top level view of how analytics should be, right? So as I said a couple of slides back, right? I mean, while there is a revolution that is happening, to me, it is an evolution, right? Now, when we talk about revolution is largely uncontrolled, right? It is fueled by multiple factors, whereas evolution is a lot more controlled, right? And what you see on the screen is again a representation of how there are different stages within the analytics industry, and this applies to any domain, be it FMCG marketing domain, be it pharmaceutical domain, be it the teaching domain, any domain, right? I mean, because there's a lot of data, there is always a keen interest, right, and eagerness that we should look at the future, right? As right at the start of this conclave, as Hema ma'am said that we know the past, we understand the present, and we have the ability to know the future or predict the future. That's exactly what this is talking about, right? So we start with descriptive analytics. Now this is what is going to be the most interesting part of it, because when you have the data, say for example, the number of times you have opened WhatsApp or Facebook in each of the 30 days of the month. If you're going to record this, right? Then you will look, okay, let me take the average. Let me understand that, what is the average time I have spent on a day? What is the average number of times I've opened the Facebook account, and so on and so forth. This is what is called as descriptive analytics, right? Now, when you go a step further, saying that, okay, fair enough. Now, it seems that perhaps during the weekends, right, during Saturday, Sunday, the average number of times when I open the Facebook app or WhatsApp, it goes up, right? Why did it happen? Now, this is what you would call as diagnostic, because you would say that, okay, it's a weekend, so therefore I naturally have more free time in my hand. Therefore, I naturally tend to spend more of the time in the social media, right? That is what we call as diagnostics. And now going forward, right, how am I going to behave for the next month? Which is what the predictive analytics is going to be. Understanding that, how many times I have opened WhatsApp and Facebook application in the past 1 month during weekdays and during weekends. How am I likely going to behave in the next one? That is what is obviously predictive. And the last one is I would say, it's not a recent invention or innovation, but this is something which is gaining a lot more traction, which is prescriptive analytics, right? Where you may decide, saying that, okay, I realize that I'm spending a lot more time on Facebook and WhatsApp than how much I would want to. Rather, I would want to sort of spend some time for some sports. How should I do it? Which are the times, which are those days where I'm spending a lot more time? Now, this is exactly what we call as prescriptive, because using your past diagnostics and insights, you're trying to change the behavior of the future, right? And since most of you will fairly soon enter into the employment part of the life, your professional part of the life, I've just put it, given a perspective of how difficult it is and what is the value that one you bring to the table, right? So the x-axis represents difficulty and the y-axis represents value. The maximum value, as you can see, comes from the point that, when you're talking about predictive, what will happen tomorrow and how can you change the future. That is where you bring the maximum value, because you're really telling somebody that you can change the future. Obviously, that has a lot of value, right? And difficulty, and exactly that is again where the maximum of the difficulty comes into picture, right? Because there are a lot more techniques, a lot more complicated and sophisticated techniques that comes into picture. So you would want to use multiple different techniques and methodology and approach to when you're talking about predictive and prescriptive part of the analysis, right? So this attempt is more to sort of give a snapshot of how it is. And yeah, I mean, I would say this is perhaps my last slide. A bit of a more philosophical take with respect to how we can maximize value in this field, because as I started talking about the data explosion, I started talking about the concerns this data explosion is bringing and how we can help, right? While there are specifically multiple ways to help, there are 5 specific value driven behavioral aspects that I could pick up when I look back at my 15 years of working experience. And I think, if today, if I were to rewind my life and I were to say that, okay, how am I going to relive those years? How am I going to better my behavior? How am I going to better my decision making ability? These are the 5 specific things that I would kind of pick up, right? First and foremost, to start from the bottom of the slide, be a partner, right? Do not look at things, do not look at anything from a formality perspective, or merely to do things, right? Get involved into it, become a partner, own it, which means that, if you almost think of every single problem that you're encountering where you need statistics to be used as a problem, which is the last problem in your life that you will solve. And it has a far reaching impact, right? And for every problem that you solve, try to attach a value to it. So for example, don't simply say that the average is so and so, the standard deviation is so and so. Try to take it a step further. Try to see that, if you were to convert this into simple non-technical language, what does this mean? So for example, I was kind of continuously observing the number of participants in this conclave, how it is changing, and I quickly noted down. So I captured 30 observations. Okay. And what I saw is that in this 30 observations, the number of participants in this conclave was changing from 137 to 141. Okay, and 137, 140 is a massive attendance. So I was very happy. So I thought, like, fairly, it seems to be a fairly tight confidence interval. Let me see what is the coefficient of variation, right? Because I wanted to sort of, feel happy about it. So when I calculated the average and when I calculated the standard deviation and when I calculated the coefficient of variation, which is standard deviation divided by the mean, I could see the coefficient of variation is as small as 0.01. What does it mean? It means that the attendees, the participants in this conclaves, they are highly engaged, they are highly enjoying the sessions, and that's the reason you don't see too many participants leaving. Now the story has changed. I see only 114 participants. I don't know if my session is too boring, but the point that I'm trying to make out here is that when you use statistics, when you make some decision, ensure that you're interpreting it in the right way, right? Because if you think about it, right, you're telling the government that the next pandemic or the next wave is going to start in Goa instead of Assam. If we say that to the government, and let's assume that the government takes it, which means that the government is going to put all its resources, all its medical staff in Goa, right? Everything to avoid the next wave or the next spurt of cases. Whereas in the state of Assam, there are cases already shooting up, right? And unfortunately, the government has pulled all the medical staff from the Assam state to the Goa state, right? It can spell disaster. It can be highly adversely impacting, because the only way the data can be used, any data can be used in today's world, is through statistics. And statistics is a means to interpret data. So if you make a wrong interpretation, you are really creating a lot of trouble. You're really creating a lot of challenges for yourself, because remember, we all are part of this world, right? I mean, take for example the COVID scenario, right? It's not that only one of us or only few of us are impacted. A lot of us have lost our near and dear ones, right? And if the hypothesis that it has got leaked from a China lab is indeed true, right? And if things would have been taken care appropriately, and if the right set of data would have been released with the right interpretation, perhaps this disaster, this pandemic could have been avoided, right? So, uh, friends, my dear students, uh, please take my words, again, as I'm saying, this is a friendly advice, because nobody is going to, once you get into a job, nobody is going to tell you, you know what, do not reduce the confidence level from 95% to 85%. How is that going to impact? Nobody is going to tell you. It is you, me, all of us who have been through this journey of statistics, for us to decide that by increasing the confidence margin, which is from 95%, if we are bringing it down to 80-85%, which means that we are increasing the error margin. And therefore, the risk of us making a wrong decision, or rather, the risk of our right decision becoming incorrect is increasing, right? So be extremely careful. Again, as I said, my intention is not to scare you away, but my simple intention is to say that, if your basics, if your fundamentals of statistics are clear, then no matter how difficult a technique is, be it machine learning, be it artificial intelligence, you will be able to understand that very well. On the contrary, if you do not know what is the meaning of coefficient of variation, or you do not understand how is the standard deviation and standard error different, then no matter whichever courses you do, at some point of time in the future, you are going to stumble. At some point of time, you are going to encounter some hurdle where you will have to refer to your basics, where you will be faced in a bit of an embarrassing situation, saying that, I'm not able to make sense of the basics, and that's not a good feeling, right? It's almost like saying that, we are unable to read a simple English word, or we are unable to say, for example, speak in our mother tongue, right? For example, right? So I think that's the biggest takeaway that I have. And as I said, I don't feel that I am, equipped enough to give a lecture on theory, because that is for our faculties or teachers or veterans in the academic field, they are the masters and they are best suited for that, right? I don't think I can take that position, right? But what I can definitely want to give back to the society, because as I said, I have been a part of you. I've been a student, and I strongly feel for this field. I strongly feel for this academic institution, and I know how much of the efforts and time that you all are putting in, right? So this session for me was more of an attempt to connect with all of you individually at an emotional aspect. Yes, indeed emotional, because statistics and data has an emotional side. It has a social side, which we often tend to ignore, right? Because we have the software, we have the equipment and everything to kind of use it, but unfortunately we don't often realize that one small mistake in terms of interpretation, one small mistake in terms of decision making can create havoc. Not to mention that it can lead to us losing our job, but that's a different thing, right? That's a secondary thing, right? We all want to be good human beings, right? So and yeah, I mean, the last point mentioned out here, which is democratize personalized insights. This is nothing but what I'm doing currently. I mean, I could have not given this session. I could have chosen some other topic, but I strongly felt that if I have made a mistake, I wouldn't want you all to make a mistake. I would want you to start on the right note. I would want you to become successful, and that can only happen when I'm going to share my learnings with you. And that is what I meant by democratizing my personal learning and my personal insights, right? And that's exactly what our dear teachers and faculties and professors do, right? They keep on guiding us, they keep on giving us the right direction. Okay, that really brings us to the end of my presentation. As I said, it is supposed to be more of a walkthrough, a bit of a attempt to open your eyes to the other side of the world, other side of statistics. It is also to say how crucial is statistics, right? I mean, and as I said, I feel fortunate to have gone through this journey. I feel honored to be part of this conclave and being able to share this learning, right? So yeah, I thank you all for listening to me. Of course, we have a few minutes left, I guess. So I'm happy to take any questions. If no more questions, I'm available. At any point of time, and Asha ma'am, Pratiksha ma'am, they will have my email ID or phone number. So yeah. Thank you once again, and enjoy the conclave. I think it's a fantastic opportunity for all of us to come together and see each other. Over to you, Pratiksha ma'am. Thank you once again.
So dear participants, if you have any questions, you can put them in chat box and we can take a few questions. Okay, so there is one question by Advait. With the chip shortage crisis, can one still be optimistic about the future of data and computing?
Sure. Advait, thank you for that question. Well, it's a good question, right? Now, I would like to take confidence from the human evolution, and maybe my answer, you may find it a little philosophical, but I do choose to keep it that way, right? See, whenever there is a challenge, right, in humankind, what you will realize that, we have always overcome that challenge through some way or the other. For example, before artificial intelligence, before machine learning, geospatial analytics, everything came into picture, right? We all, the human mankind was really staring at a juncture where we were struggling to say, how can we increase our computing speed? How can we do calculations? How can we run regression with, say, 100 independent variables and still be able to get the most correct set of predictors, right? What happened then, right? Suddenly there was what is it, a sort of an evolution, a revolution that came in the field of computing. And the weather forecast, the geospatial and the geospatial analytics, and all sort of advanced technologies that today exist in the world is only because we have far more super powerful computers which can crunch numbers in a fraction of a second, right? Now, the chip shortage crisis, particularly the one that you're talking about, well, I don't think it is any future threatening. It's a temporary blip in the exponential curve. And remember, the exponential growth of data is not dependent on this, right? The exponential growth of data is completely dependent on you, me. Say, for example, for the next 1 month, if we are not going to visit any of the malls, if you're not going to use social media at all, that is a way we can perhaps reduce the big data, right? But again, that's not a practical solution, right? Let's accept that, right? I mean, it doesn't, see, this webinar, we have been able to celebrate this conclave because we have the technology, because we are able to host this webinar, right? So it's not the case that this is a totally bad thing, right? It is about how can we manage it, how can we direct it in the right way. So if you take if you ask my opinion, my personal opinion is that the chip shortage crisis is a temporary blip. It's about manufacturing, and there will always be, there would already been some kind of a solution that would have come in. Chip is more in terms of the storage, the computation part of it. But by the time it will even have a bigger hit to the industry, it will take a bit of a time. So I would still be optimistic about the future of data and computing, because otherwise we are going to go back to a time where we will be completely disconnected, and we will be kind of taking sticks and lighting fire through matchbox, rubbing stones and everything. And I don't think that's a practical scenario that we will be. I don't know if that makes sense to you, Advait, but that's my take on it.
Thank you, sir. Are there any more questions? Participants, if you have any questions, you can even unmute yourself and speak. Okay. So Advait is satisfied with the answer. And I must tell you that we have participants from various parts of India, and they all have enjoyed your session. So it was not at all boring the way you thought, looking at the numbers keep fluctuating. So thank you so much, Prashant sir, for your wonderful and eye-opening address. We were happy to have you with us. Thank you so much.
Sure.
So we'll move ahead now. We have amongst us Professor Anup Chaturvedi, former professor from Department of Statistics, University of Allahabad. Sir is going to guide us about the time series SARIMA modeling. Sir was superannuated after his service of 38 long years. He is a fellow of Royal Statistical Society. He has published 2 edited volumes entitled Handbook of Applied Econometrics and Statistical Inference, published by Marcel Decker Publishers, USA, and Some Recent Developments in Statistical Theory and Applications by Braun Walker Press, USA. He has more than 100 research publications to his credit, and Sir has been a research fellow and visiting faculty for many universities abroad. Sir has supervised 20 plus PhD students, and he is also involved in editorial activities of several journals. We are blessed to have you with us today, sir. Now I request Professor Anup Chaturvedi, sir, to deliver his talk. Over to you, sir. Asha ma'am, sir is not connected yet.
Please ask, hello, is
Yes,
that
ma'am.
audible? Yeah, please ask Aradhna madam. Aradhna madam?
I think sir got disconnected. He had joined in between.
Do I connect once again and identify?
Yes, ma'am. If you can.
Yeah.
Participants, by that time, you can fill up the feedback form for first 2 sessions. We have floated the feedback form for first 2 sessions. I'll request Suraj to put up the link of both the forms once again.
Okay, ma'am.
I think second form link is here. You can put up the link of first form also.
Yes.
Yes, Pratiksha, he is joining soon. He has
Okay.
just finished with his earlier function, so he
Okay.
is joining soon.
All right, ma'am. So, ma'am, by that time, if any participant want to speak or
Yeah,
give
anything? Yes, please.
feedback,
About the any feedback, anything.
if
They
you
have
want to give us
their
any
time.
suggestions or feedback,
And even I will request meanwhile uh, Kismat to talk about the next event rules, and Sir's talk will be there for nearly 1 hour. Then half an hour break we are giving, and then we'll join. So I think so that rules Kismat can talk about it right now. Kismat, are you there? Can you unmute yourself and speak out the rules of your crossword? Hello. Yes, Durai sir. Namaskaram.
uh,
Kismat.
Hello. Yes, ma'am. Ma'am, sorry. There was some network issue. I was not able to hear you.
Yeah, I asked that. You can, meanwhile, you can give them what are the rules for the crossword competition.
Okay. Okay, ma'am.
So they
Uh,
will be ready when they are having it after 1.5 hours.
okay. Suraj sir, can you give me access? I would like to share my screen.
You are co-host. You have already that access.
Okay. Okay, ma'am. Hello, everyone. Good morning. First of all, very happy National Statistics Day to everyone present here. We know you know that you have crossword also. It's a fun game. We are going to have it after break. So before that, I would like to explain you some rules of crossword which you need to know before starting the game. So first of all is it's an individual game, and you will be having 50 crosswords which you need to solve in 45 minutes. I'm again repeating, you will be having 50 crosswords, and the timing allotted for that is 45 minutes. Then second is answers to be filled in Google form. We will provide you link for Google form before starting the crossword session. So in that you need to fill the answers. Question will be there in answer in that Google form only. If required, we will share that question paper in your WhatsApp group also, or in chat box, so that you can get that. Then third and very important part of this crossword is, please everyone note down, you need to write down the answers in capital letters only. If you are writing answers in small letters, if you are using spaces, special characters, then in such cases your answers will be considered as incorrect. You only need to write all the answers in capital letters in the Google form,
Without spaces.
without spaces or any special characters. So just write the answers using the capital letters. And yes, 50 crosswords will be there in screen. I will display the grid, and yes, I will share that on your WhatsApp chat so that you can get all the things. So there are few routes of crossword. First of all is, you need to fill the Google form. Answer should be in capital letters. Time allotted is 45 minutes. So I hope that everyone is clear about the rules of crossword. If anyone have any doubt, please ask me in chat box. Yes, is it clear? Okay. Okay, then okay. Okay. So yes, this was the route. I'm stopping my share. Okay, ma'am. So before starting the crossword session, I will share the grid with them. For now, this rules explanation of rule is fine, I think.
Yes, sir has joined.
No, I don't think so. Has sir joined? I
Right.
can't. No.
So do we start this competition first?
Um,
45 minutes ka?
but if sir is joining in between, I think we have to ask sir once.
Or
Can we?
meanwhile, Pratiksha, meanwhile, your doodle making, can we bring it doodle making here? Because already
Then we'll have to, I think, Monish, can we stop live on YouTube now? Ma'am, shall I start?
yeah, please.
Okay. So welcome back, sir, again. So we have amongst us Professor Anup Chaturvedi, who is former professor from the Department of Statistics, University of Allahabad. Sir will be guiding us about this time series Sarima modeling. Sir was superannuated after his service of 38 long years, and he is a fellow of Royal Statistical Society. Sir has published 2 edited volumes entitled Handbook of Applied Econometrics and Statistical Inference from Marcel Decker Publishers, USA, and some recent developments in statistical theory and applications from Braun Walker Press, USA. Sir has more than 100 research publications to his credit. He has been a research fellow and visiting faculty for many universities abroad. Sir has also supervised 20 plus PhD students, and he is also involved in the editorial activities of several journals. So we are blessed to have you with us today.
Thank you.
I request you to deliver your address. Over to you, sir.
Thank you. Sir, you can hear me?
Yes, sir.
Yes, sir.
I'm going to share my screen now. So can you see the screen?
Not yet, sir.
You have not shared this.
Pratiksha, is he co-host? Sir, now try. I think so multiple participant sharing access is given.
Yes, sir, is a co-host.
Yeah.
Now, can you see the screen?
No, sir, we can't see your screen. So you have to share the screen. From
Yeah, that's what I am doing.
Yes, sir, now the screen is visible.
Okay, thank you very much. And I wish all of you a very happy 15th National Statistics Day. So the title of my talk is on seasonal ARIMA processes. And then this is the outline. First, I will introduce the basics of seasonal process or seasonal variations of time series. Then just I will give you a brief introduction of ARIMA models. Then the concept and types of seasonality and SARIMA model. If I will get time, then I will also give you the details of ACF of SARIMA model and finally some concluding remarks. Now, at undergraduate level, many of you must have studied the traditional approach of time series analysis. And in traditional approach, what we do, we decompose the variations in time series into 4 different components according to the nature of the variation. The long-term movement of the time series, which is called secular trend. Then you have cyclical component. And as all of you know, the period of cycle is usually more than 1 year in cyclical components. You have seasonal components, which has a period of oscillation less than 1 year. And finally, random or irregular components. Without random components, you cannot work in the statistics. This is the component which makes your time series a random variable. And time series, you know that the current observation is affected by past observations or past shocks. In usual statistical inference, we assume that all the observations are identically and independently distributed. Ordering of the observations does not matter. It makes no difference in drawing inferences from the observations. But time series observations are not independently distributed. So the current observation may depend upon the past observations. Or you can say the past observations and past shocks also have some information about the current observation. Now, the Box-Jenkins approach is based on this logic. In Box-Jenkins approach, what we do, we try to model the current observation as a linear function of past observations and current and past shocks. So we assume that both past observations and past shocks are affecting your current observation. And that's why you write the current observation as a linear combination of these 2 things. In time series analysis, often you observe non-stationary behavior also. And this non-stationary behavior may be due to the presence of trend component. It may be due to the presence of unit roots and so on. One of the reasons may be the presence of seasonal behavior. This may also cause non-stationarity in the time series. Because if seasonality is present, then mean of the observations is not constant. Mean of the rainfall in July is obviously different from the mean of the rainfall in January or May. So it does not remain constant. It evolves according to a cyclical pattern. So you have some kind of periodicity. There are many examples of seasonal time series. You must have studied, say, monthly rainfall in Delhi. The rainfall is not constant and varies by months or quarters. For the same month in different years, we expect a constant expected value. You may expect the same expected value for rainfall in the month of June for 2019 or 2020 or 2021, provided it does not have any trend. Or even if it has any trend, the trend has been eliminated. Then there are many methods for obtaining seasonal indices, which all of you must have studied at undergraduate level. Simple averages method, ratio to trend method, method of linked relatives, etc. Now, the problem with all these methods is that these methods are unable to provide a link between current observation with the past observations due to seasonality. Means this is actually the basic difference between classical approach of time series analysis and Box-Jenkins approach also. In classical approach, we impose the 4 variations on your data. It has trend, it has seasonality, etc. In Box-Jenkins approach, the observations evolve, or the current observation has a link with the past observations. Now, just in brief, I will introduce the ARIMA models and then I will come to the main topic. So YT is a time series. Capital T is the set of all possible values of T. Then how we define the moving average process of order 1? MA, we also denote it by MA1 process. We write YT equal to mu plus UT minus θ1 UT minus 1. So mu is the mean of the process. UT is always there, the present shock, the present error term, you can say. But apart from that, you also assume that YT depends upon just one period lagged shock, UT minus 1. So YT is generated by mu, the process mean. It has impact of UT, the current shock, as well as one period lagged shock, UT minus 1. Now, in terms of backward shift operator, you can write YT as mu plus 1 minus θ1 B UT, where B is the backward shift operator. B UT is UT minus 1. B, if you replicate this backward shift operator J times, so B J UT is UT minus J. You can easily obtain the variance of the process, which is sigma square u 1 plus theta 1 square. Then you can also derive the autocovariance function. Actually, autocovariance function is obtained by the covariance between yt and yt minus k. You know, the time series, different time series observations are autocorrelated. They are correlated with each other. So their covariances may not be zero. For MA1 process, gamma 1 is equal to the first autocovariance coefficient is equal to minus theta 1 sigma square u. And apart from that, gamma k is 0 for all k greater than 1. So you can also write the autocorrelation function, which gives the correlation coefficient between yt and yt minus k. We denote it by rho k, which is equal to minus theta 1 upon 1 plus theta 1 square for k equal to 1, and for k greater than 1, it becomes 0. Now, similarly, you may define the moving average process of order q, which is given here. So in moving average process of order q, we assume that the current observation is generated by the current shock as well as by ut minus 1, ut minus 2, so on ut minus q. So up to q period lag shocks. Then you can write yt as the MAQ process as yt equal to mu plus theta b ut. Theta b is taken as, this is also an operator, which is defined as 1 minus theta 1 b minus 1 minus theta q b to the power q. Now this is the ACF of MA2 process. So for MA2 process, I have not given the expression, but the ACF vanishes after lag 2. In fact, for MAQ process, the ACF vanishes after lag 2. As I told you, for MA1 process, the ACF vanishes after lag 1. Right? So this is the beauty of moving average process. The autocorrelation function vanishes after certain period. Now we define autoregressive process of order 1, AR1 process as yt equal to say phi 1 yt minus 1 plus delta plus ut. So here we assume that yt is affected by one period lagged values of y, means yt minus 1. This process is also called the Markov process because it satisfies the Markovian property. Given yt minus 1, it becomes independent of the past values, yt minus 2, yt minus 3, so on. Or you can write AR1 process as 1 minus phi 1b yt equal to delta plus ut. And then you can easily derive the autocorrelation function of this process, which is equal to rho k equal to phi 1 to the power k. Now here we assume that mod of phi 1 is less than 1. So if mod of phi 1 is less than 1, then how this rho k behaves? Rho k declines exponentially because mod phi 1 is less than 1. So if you increase the value of k, rho k decreases. Phi 1 to the power k decreases. Now why you require this kind of condition? Mod of phi 1 less than 1. Suppose you take phi 1 equal to 1, then see what happens. So I don't have time to go into the details, but I'm just giving you some idea. Say if you take phi1 equal to 1, then yt can be written as yt minus 1 plus delta ut, delta plus ut. Now you replace yt minus 1 by yt minus 2 plus delta plus ut minus 1. So you get yt minus 2 plus 2 delta plus ut minus 1, and so on. You keep on moving, then ultimately you get y naught, the initial observation, plus t times delta plus summation j equal to 0 to t ut minus j. Now if you look at this process, it has two important features, two important properties. First, it looks like that the process has a linear trend. T times delta. If you plot this process, it looks like that the process has a linear trend. In fact, the original process does not have a linear trend. So that's why this kind of trend is also called a stochastic trend. Many of you may know that this is a random walk model. So, and second thing, the error term is j equal to 0 to t ut minus j. So with lag, the impact of ut minus j on yt does not decrease. So it has a long-term effect. Any shock present in the time series has long-term impact. In fact, if you derive the variance of this process, the variance becomes t times sigma square u. So as t increases, variance increases. So the process explodes. Explodes in the sense that its variance tends to infinity. Now, if you take the first difference, so although the process is non-stationary, but if you take the first difference, then it becomes yt minus 1 equal to delta plus ut. The process becomes stationary. So this is the graph of AR1 process with the phi1 equal to 0.6. So you observe that the rho k, the ACF exponentially decreases to 0. In general, for the autoregressive process of order P, ARP process can be defined as just for simplicity, we take delta equal to 0. So you can define the ARP process as 1 minus phi1b minus phi2b square, so on minus phi p b to the power p, yt equal to ut. Or you can write it as phi b yt equal to ut. So this is your ARP process. Again, I'm not going into the details, just I'm giving you a brief idea of all these processes. Then we may define the ARMA process also. The ARMA process has both autoregressive terms as well as moving average terms. So phi b indicates your autoregressive terms, phi b yt, theta b ut, this indicates your moving average terms. Order of autoregressive term is p, order of moving average term is q. So that's why this process is called ARMA PQ process. P denotes the order of the autoregressive term and Q denotes the order of the moving average term. In general, as you have observed for the random walk model, if the process is non-stationary, you take the first difference, it becomes stationary. In general, suppose your original process is non-stationary. But if you take the d differences, then it becomes a stationary ARMA PQ process. Then we say that yt follows an autoregressive integrated moving average or ARMA PDQ process. So ARMA PDQ process means you take dth difference of yt, then the process becomes stationary. And this dth difference follows ALMA PQ process. And we write it as phi b delta d yt equal to theta b ut. Now we come to the seasonal processes. Again, yt is a time series, and either trend is not present or we have already removed the trend component. And suppose yt has seasonal component, and so it has seasonality, and period of seasonality is S. So whenever we say that the period of seasonality is S, it means if you take expectation of yt, and expectation of yt plus S, then these two expectations are same. For example, for rainfall data, expected rainfall for July 2019 is same as the expected rainfall for July 2020 or expected rainfall for July 2021, because the period of seasonality is 12 months. So expected value of yt is equal to expected value of yt plus S for all t. So this expected value of yt varies in its cyclical pattern, but it is a function of S. So it depends upon S. You can write it as a function of S. Say ST. For monthly seasonality, S is 12. For quarterly seasonality, S is equal to 4. You can have weekly seasonality also. On Sunday, you may find more people in the restaurants. So S is equal to 7 in that case. Now you observe this graph. This is the monthly data on ozone contents in the atmosphere. So the data has a slightly decreasing trend as well as seasonality. To make the picture more clear, you may plot the graph for different months. So this is the graph for different months. So from this graph, you may observe that the ozone content in January is always less than that in May, or May is generally less than that in September. So this kind of conclusions you may draw from this graph. Or another option is to observe the seasonal behavior. Let us draw the time series for different months. So this is the time series for January. This is the time series for February, March, April, May, June, and so on. And then we have also plotted the mean, the average value. This average value may be the arithmetic mean or median. So it depends upon your choice, which measure of central tendency is more appropriate. You have to select. But if you look at these average values, then you observe some kind of seasonal behavior. It has decreasing trend as well as this seasonal behavior. Now, sometimes if you have very high frequency data, your time series is very long, then instead of plotting this entire time series, you may use the box plot. Okay. So now we assume that except for its seasonal effect, the series is stationary and S is fixed. So you write yt equal to STS plus eta t. STS is the seasonal effect of period S at time T. And eta T is the stationary part after eliminating the seasonal effect. Expectation of eta T is equal to nil. So it has constant mean. It is a stationary process. Expectation of YT is then expectation of STS plus mu. Now, this expectation of STS is not constant for all S. So this series is non-stationary, right? Now we consider three different cases, three different types of seasonality. And then I will show that for all these three types of seasonalities, you can use the Sarima processes. The first case is when seasonality is a deterministic process. So STS is equal to STK plus S. So it's a constant function. So after period Ks, it is going to repeat itself. For example, if STS follows a sinusoidal function, like sine wave or cosine wave, which occurs in climate series due to Earth's rotation. But occasionally what happens, representing the seasonality component with sinusoidal functions is not very efficient. One can also use 11 dummy variables, one for each month of the year. Okay. Now the second case is seasonality evolves over time as a stationary process. So STS is a stationary process oscillating around a mean value mu s. So STS can be written as mu s plus mu t. Mu t has mean 0. So basically, this mu s is the deterministic effect of seasonal depending on S, and mu t is the stationary process and introduces variability in STS. Because remember, although we say that seasonality is periodic, it is oscillating, but those periods have some variability also. Means rainfall of June of 2019 is not the same as the rainfall of June 2020. So there is some variability, and that variability is introduced by mu t. Third case is when seasonality changes over time with no fixed average value. So it's a non-stationary process. So suppose STS evolves according to a random walk. So it's a non-stationary process. STS is equal to ST minus S plus mu t. Mu t is a stationary process. Now you define the difference of operator of period S. Del S equal to 1 minus Bs. Del S YT is equal to YT minus YT minus S. Then applying this operator del S to 1, you have del YT is equal to del S STS plus the first equation is YT equal to STS plus eta t. So del S YT is equal to del S STS plus del S eta t. Now remember the eta t, you have assumed that it is a stationary process, so it does not create any problem. The only problem is with the STS. We have considered three different cases, and for all the three different cases, we are going to show that this first part is also stationary. So suppose you take the first case, when STS is deterministic, then if you take the difference, the seasonal difference, del S, then it becomes 0. So ultimately, del S YT is equal to del S eta T, which is also a stationary process. Eta T is a stationary process. So any difference of eta T is also a stationary process. The second case which we have considered is when STS is a stationary process. STS is equal to mu S plus mu T. Again, if you take the asset seasonal difference, then this part becomes 0. So you get del S mu T. So del S YT is equal to del S mu T plus del S eta T. Again, this is a stationary process, so it's asset seasonal difference is also a stationary process. This is also a stationary process. So this entire process is a stationary process. The third case is when STS is a non-stationary process. You assume that it is generated by a random walk. Again, if you take the asset seasonal difference, then the resulting process is a stationary process. Take the difference, then what you get here, del S STS is equal to mu T, because it does not depend upon S. So it becomes mu T. So it is a stationary process. So in all the three cases, we have shown that if you take this seasonal difference, then the ultimate process becomes stationary. This result is actually the basis of Salimer model, of defining Salimer. So now you have the time series YT. Suppose your time series is non-stationary, then this non-stationarity may be of two types. First, it is non-stationary because it is a random walk. Or if you take the D differences of this series, then it becomes stationary. D regular differences, not the seasonal differences. So after taking D regular differences, this non-stationary part vanishes. Which non-stationary part? Which is caused by this random walk. And then to eliminate the non-stationarity due to the seasonality part, we take the seasonal differences. So to convert a non-stationary series with both seasonality as well as the second kind of, the first kind of non-stationarity, we use the transformation del S D del D YT. Capital D is the number of seasonal differences. Usually we take 1 or 0, 0 when there is no seasonality, and 1 when there is seasonality. But sometimes you have more than one kind of seasonalities also. Means you have monthly seasonality as well as weekly seasonality. Although then the problem of estimation may be more complicated. And small d is the number of regular differences. Means like YT minus 1. And usually we don't go for small d beyond 3. Even 3 is a large number. Because each time you difference, you lose some information. So we model the regular and seasonal dependence separately, and then we construct the model incorporating both multiplicatively. So what we have done, this is your autoregressive, regular autoregressive operator of order P. Then you also have a seasonal autoregressive operator of order capital P. This is your seasonal autoregressive operator. This theta q is your regular moving average operator of order small q, and capital theta q bs is your seasonal moving average operator of order capital. Right? Now this is your Sadima model. Seasonal autoregressive moving average, so seasonal autoregressive integrated moving average model. Right? Again, I repeat, this model has a small d differences corresponding to your regular non-stationarity. It has capital D seasonal differences corresponding to your seasonal non-stationarity. It has these this autoregressive operator corresponding to regular autoregressive trend. This seasonal autoregressive operator corresponding to seasonal autoregressive trend. Similarly, this also has regular and seasonal moving average operators. Right? UT is your use of white noise process. And we write this model as, sorry, I should have written S also. S is missing here. So Sadima P D Q cross capital P, capital D, capital Q, and this S denotes the period of seasonal process. So this model provides a good representation of many seasonal series. One can also derive the autocorrelation function for this process. So suppose now for deriving the autocorrelation function for this process, first I'm going to define the autocovariance generating function. So suppose gamma k is the autocovariance function, then we define the autocovariance generating function as gamma b equal to summation k equal to minus infinity to plus infinity gamma k b to the power k. And then suppose you have this general linear process. Then for this general linear process, this is the autocovariance generating function. Now from this autocovariance generating function, how to get the different autocovariances? The procedure is very simple. Now this is a polynomial in B inverse, this is a polynomial in B. You multiply both the polynomials. Then first you collect the coefficients of say b to the power 0. That will give you gamma 0, means the variance of yt. You collect the coefficients of b, that will give you gamma 1. Collect the coefficients of b square, that will give you gamma 2, and so on. So finally, if you collect the coefficients of b to the power k, that will give you gamma k. Now for Sadima model, this is your stationary process. And you can break it into two parts. Or you can say two different processes. This is your regular ALMA process. ALMA PQ process. And this process has just seasonal parts, seasonal autoregressive and seasonal moving average operators on K. Now, both these processes are stationary processes. And you know that if there is any stationary process, you can always write it as a general linear process. So you can you write the first process as a general linear process, this. You write the second process as a general linear process, ZT equal to this. Right? And then X3 can be written as in this form. Psi B, capital Psi B as UT. So this is also a general linear process. So what we have done, first we have written the Salima process. Is first we have removed the non-stationary part after taking the differences. Then we have written the process in two parts. First part, equation 7, as just ALMA part, the regular ALMA part, and the second part, equation 8, has just seasonal, autoregressive, and moving average parts. Then we have written both of these parts as general linear process, right? And then you can combine these two in this form, right? Now suppose Ci is the autocovariance, Ri is the autocorrelation of ALMA PQ process, 7 or 9. Then how can you get Ci? It is the coefficient of B to the power I in this. Psi B in this. Similarly, capital CSJ is the autocovariance of, and RSJ is the autocorrelation of seasonal ALMA PQ process 8 or 10. Then this is the coefficient of B to the power Sj in this. So ultimately, gamma K or rho K are the autocovariance and autocorrelation of the process. 6 or 11 means the Salima process. Then you can easily obtain gamma K as the coefficient of B to the power K in this. Now, you know the coefficient of B to the power J in this part. You know the coefficient of B to the power Sj in this part. So you can easily get the coefficient of B to the power K in this product. So ultimately you get this expression for gamma K, which you can easily find. For K equal to 0, you get the variance of the process, and then you can get the autocorrelation function, rho K. So for different values of S, small p, small q, capital P, capital Q, you can easily calculate rho K. Okay, let us see all these graphs. And these graphs will make the picture more clear. Here you have MA112 process. So it does not have any regular ALMA component. It has just a moving average component, seasonal moving average component of order 1. The value of theta is 0.6. Now, it has non-zero autocorrelation at point K equal to 12. All other autocorrelations are equal to 0. Now, how the autocorrelation function for MA1 process behaves? Autocorrelation rho K for MA1 process is non-zero for K equal to 1. For all other values of K, it is 0. For MA112 process, for k equal to 10, it is non-zero. For all other values, it is 0. If you consider this process, AR112 process, then it is non-zero. It does not have any regular autoregressive or moving average term. It does not have moving average, seasonal moving average term. So this decreases exponentially with non-zero values at k equal to 12, k equal to 24, k equal to 36. Here actually s is equal to 12. We have monthly data. Now if you consider MA1, MA12 process. Now MA1 process has just one autocorrelation coefficient non-zero, which is at k equal to 1. Here also at k equal to 1, you get this non-zero value. Then this seasonal part you have, theta is minus 0.5. So you have negative value of rho 12. But not only these two values, two adjacent values are also non-zero. And these values are actually symmetric, means this value rho 11 is equal to rho 13. So the autocorrelation function of MA1 cross MA12 process behaves like this. If you consider MA112 process with theta equal to 0.5, then it behaves in a similar manner, except that these autocorrelation coefficients are non-zero. Now, if you consider AR1, MA112 process. Now, how the autocorrelation function of AR1 process behaves? The autocorrelation function decreases exponentially. But because of this MA112 term, it again starts increasing, goes up to this value for k equal to 12, then it starts decreasing. And since the order of this seasonal moving average term is 1, so after that you get no other such kind of increase in autocorrelation function. It just decreases exponentially, just like the autocorrelation function of AR1 process. The impact of this term vanishes after this here. Okay, so suppose you have this process AR1, AR112. So you have usual AR1 term and then seasonal AR112 term. So the autocorrelation function behaves like this. It decreases exponentially, again it starts increasing, decreases exponentially, then goes up to this point, it starts, it increases, then decreases, it again starts increasing, goes up to this point, decreases, and so on. And if you look at these points, these maximums are also decreasing exponentially. So this is how the autocorrelation function of all these processes behave. We have considered an example also. We have taken ZT equal to del 7 YT, and then we have calculated the autocorrelation functions for all these processes also. Well, I am not going to much details, but we have plotted the autocorrelation functions for real data also. So here are some concluding remarks. So seasonal autoregressive integrated, sorry, this should be M, moving average model accommodates both non-seasonal and seasonal factors in a multiplicative way. And this multiplicative model can be generalized for more than one type of seasonality also. Here we have considered just one type of seasonality, a seasonality with period S. But sometimes in applications, you may have more than one type of seasonality. Although in those cases, estimating the coefficients becomes more tedious, more difficult. So there are some differences. You may go through all these books. That's it. Thank you. Any question?
Yes, thank you so much, sir. Are there any questions, dear participants? If you have any questions, please put them in chat box, or you can unmute yourself and speak. If there are any questions, please put them in chat box, or you can unmute yourself and speak. So I think sir has very nicely explained the SARIMA modeling, and his students, participants don't have any questions right now. So we'll go ahead with our program. Thank you so much, sir, for your very enlightening and motivating and very informative address. You have explained it, the time series SARIMA modeling very nicely and very systematically. We are happy to have you with us today, and thanks once again on the behalf of Department of Statistics. So,
Well, actually, sorry to interrupt.
yes, sir. Yes, sir.
If there is no,
There is one question, sir. Yes, there is one question right now. So Adil Kamal is asking how heteroscedasticity effect affect time series.
heteroscedasticity in what? In random component or in UT, or I think in UT.
Yes, Adil, you can unmute yourself and speak also. In what? Yes, UT is saying.
UT, okay. Yeah, then the problem will be more complicated. Then you have to go for some processes like R or GALC processes. And those models, your variability also is the variance of UT, you assume that sigma squared T, and sigma squared T is also generated by some process. So problem will be more complicated, but you can find work on ARC and GALC models also.
Yes.
So one thing I want to mention that in SARIMA models, we take the seasonal part of the operator and the usual part of the operator in a multiplicative way. Now, if you don't consider this kind of multiplicative way of constructing the model, then imagine what will happen if, without taking into consideration the seasonality, you plot the ACF, then you will get this kind of ACF which I have shown you. Okay, and then what you will do, you will fit an a moving average model of order 12 or 13 or 14, or an autoregressive model of order 36 or 24. So then that will be very tedious. Is in between the auto correlations are almost zero, and suddenly you have a significant autocorrelation coefficient at S equal to 12, or S equal to 24, or S equal to 36. sorry, k equal to 12, k equal to 24, k equal to 36. So if you are not going to consider the Sarima processes, then you will get confused whether you should fit AR1 model or AR12 model or AR24 model. So in those cases, if you have significant autocorrelations at some periodicity, then it gives you indication that your time series has some kind of seasonal. Okay, thank you.
Thank you so much, sir. I think almost everybody has liked the session, and they have written good comments in the chat box. So I think Asha ma'am, shall we proceed further? Asha ma'am.
Yes, Pratiksha, I'm here. Sir. Thank you very much, sir. Thanks a lot, Million, for such a short notice. You have accepted our invitation and brighten our day with your knowledge and with your expertise comments.
Friends, now we are reaching towards the end of this inaugural session. Post lunch, we have competitions for students. So before we end our session, I would like to invite my fellow colleague, Ms. Shailaja Rani ma'am, to deliver the formal vote of thanks. Over to you, ma'am. Shailaja ma'am, you are not audible. So, dear participants, the feedback form for third session is also floated in the chat box. I request you all to fill up the feedback form for all the three sessions. If you have not filled up earlier two sessions, please fill up those feedback forms as well. The same will be considered for the attendance purpose as well. So it's a request to fill up the feedback form to everyone. I think Shailaja ma'am is facing some connectivity issues. We will wait for 2 minutes. Otherwise, I will continue with the. Yes, I think Shailaja ma'am is joined back. Ma'am, are you able to? Yes, please make her a co-host. I think she is not able to unmute herself.
Yeah, hi, I'm very, very sorry. Can you hear me? Can you hear me, Pratika, now?
Yes, yes,
yes, yes. Thanks a lot. Thanks a lot. Okay. A very, very happy National Statistics Day to one and all. Okay. Good afternoon to all the dignitaries present today, and a very good afternoon to my dear colleagues and participants of the first day of our 4-day national conclave. I, Mrs. Shailaja J. Rane, would like to propose the vote of thanks to all those people who are instrumental in making today's program a grand success. First and foremost, let me thank Government of India for deciding to celebrate Professor Prasanta Chaudhary Mahalanobis' birthday as National Statistics Day. We are blessed. Also, I would like to thank Dr. Mahalanobis himself in his absence for his contributions in the field of economic planning and statistical development. I would like to thank our chief guest for today, our dear Dr. Niranjan Hiranandani sir, Provost of HSNC University, Mumbai, for his valuable inputs and making his speech so witty that with all the applications of statistics in his field, that is real estate, okay, and making the program lively. Thank you, sir. Our dear principal ma'am, Dr. Hemlata Bagla, always believes in updating ourselves. She believes in the coexistence and partnerships of academics with industry. She motivates us to search for avenues to make the learning process interactive, and she always tells us to make the students industry ready. Thank you, ma'am, for your guidance and motivating us to think big and better. In the early 1900s, statistics and statisticians were not given importance. But over the years, due to the advancement of technology, scope of statistics widened. Also, due to the interdisciplinary approach, the importance of statistics has grown exponentially. We at KC College always believes in bringing the best to address our audience. So our eminent speakers, Mr. Mukesh Jain, sir, who couldn't come today because of his other things. I think he is present somewhere else. Mr. Prashant Nair, sir, Director Nielsen, Dr. Rajesh Singh, sir, Professor, Department of Statistics, Amravati University, and last but not the least, Dr. Anup Singh, sir. Now, these people had made our statistics the best. They had explained us, they had enlightened us about the role of statistics in artificial intelligence, okay, which we missed actually today, the country's development, and also how data can be used or how the bad decisions will affect us, was very well explained by Prashant Nair, sir. Majority of the events nowadays are time dependent. Dr. Anup Chaturvedi sir's Sarima models for predictions was very, very informative. Thank you all for making us understand the importance of our subject. I would fail in my duties if I don't acknowledge the contributions of our vice principals of KC College, the 4 strong pillars of KC College, Professor Padi sir, Dr. Shalini Sinha madam, Professor Justin sir, and Dr. Tejashri Shanbag ma'am. Thank you all for helping us in conducting this program smoothly. 4 years ago, Dr. Asha Jindal had become the HOD of our department. She had thought of introducing new concepts and events which benefit students and also faculty. One such event was National Statistics Day, which she started. Initially, we started by celebrating this day on only one day, that is on 29th June. But now she had converted it to a 4-day national conclave with lots of qualitative interactions, fun-filled and knowledge-imparting games, competitions, and presentations. From the bottom of my heart, I appreciate her for bringing in new ideas. Thank you, Dr. Asha Jindal. During this pandemic period, we really understood the importance of our technical team for smooth running of our programs. Thank you, Roshan and his team, for his technical support. Nothing would be possible if we don't have our office staff's support. Thank you all. The grand success of any program is mainly due to the participants who attended. Thank you all for sparing your valuable time and boosting our energies with your interactive participation. How can I not thank my team statistics? Ms. Pratiksha for her flyers, brochures, speeches, and whatnot. Dr. Mulesh sir for his meticulous organization. Our young team, Ms. Anjali, Mr. Suraj, Dr. Aradhna, Ms. Aisha, and Ms. Kismat for bringing freshness into our ideas. Of course, our backbone, Santosh Sarvankar, for helping us behind the scenes. This program, of course, is a team effort, and a team success. Thank you all. Over to you, Pratiksha.
Thank you so much, Shailaja ma'am. Now we will have a break for lunch, and post lunch we are going to have competitions for students. So I would request students to join back around 1:30 for the competitions. Is that fine, ma'am?
Yes, Pratiksha, it's all right.
So,
It finished
students,
1:30. So
and
I think so in half an hour, they can remain on this platform and take a break. Choice is there. And then they can, because later on they should not say that there was a problem, glitches,
you can
technical
either stay back or you can join back.
choice is yours. You can be here. We are also here only, maybe around these.
Other participants, faculty members, and other participants, please fill up the feedback form and see you all tomorrow.
Not
And
tomorrow, today itself after the lunch break. After the lunch break, yeah, faculty members.
participants, I'm saying, Asha.
Participants. Yeah, faculty members, yes, please. Tomorrow join us at the 10:15 sharp. 10:15 sharp. Because tomorrow's session will start at 10:30 sharp. So please join us at 10:15. And all the student participants, either be here or please join back, because there are many more things for you.
So thank you so much, all the faculty members who have joined from the various parts of India. Hope to see you tomorrow again at 10:15 a.m. Thank you so much. And dear students who are going to participate, please join at 1:30. You can take a short break of 20 to 25 minutes. Thank you so much. Thank you so much, Monish, for handling it so well, handling the technical part so well, and making us live on YouTube. We can stop live streaming now then. Thank you so much. Asha ma'am, shall we go for the break?
Yes, please.
Thank you, everyone.
Yeah.